When we think about the beginning of everything, we usually hear the Big Bang. But have you ever stopped to wonder what was there before that? Was there really nothing? Most people think of nothing as empty space, but space itself didn't exist before the Big Bang. So, what does nothing really mean? Is it just empty space? Or is it the total absence of everything? Was there a strange kind of before that existed before time began ticking? Could there have been hidden dimensions, cosmic energy, or even unknown forms of reality waiting in silence? Before we begin, let us know where in the world you're watching from, and what time it is for you right now. Drop it down in the comments below and settle in for a fascinating journey through space. Long before stars were born, before planets were formed, and even before light first shone across the universe, there was a mystery that has fascinated scientists and dreamers alike. What came before the Big Bang? It's a puzzle with no easy answers, one that has led to many exciting and mind-bending ideas. One of the most important theories in this area is called cosmic inflation. This theory doesn't exactly explain what happened before the Big Bang, but it does try to describe what happened in the first tiny moments after it. According to this idea, the universe suddenly expanded at an unbelievable speed, far faster than the speed of light, during a period that lasted only a tiny fraction of a second, much less than even a trillionth of a second. This explosive growth set the stage for everything we see in the cosmos today. Although inflation focuses on what happened just after the beginning, it gives us clues about the strange conditions that might have existed right before our universe was born. Another big idea is the singularity theory. This theory suggests that everything, all space, matter, energy, and even time itself, may have been squeezed into a single point, smaller than an atom with endless density. This point is called a singularity. At this level, the normal rules of physics simply stop working. Time may not have existed in any way we understand it today. In fact, there may have been no before at all, because time itself might have started with the Big Bang. But not everyone agrees that our universe had just one beginning. Some scientists believe in the idea of a cyclic universe. According to this theory, the universe doesn't just begin and end once. It goes through endless cycles of birth, growth, death, and rebirth. First, everything expands from a hot, dense state. After billions of years, it might collapse back in on itself, leading to what's called a big crunch. And from that, a new Big Bang may occur. This means our universe could be just one in a never-ending series of universes, each with different versions of reality, each following its own path through time. Then there's the multiverse theory. This idea is even more astonishing. It suggests that our universe might not be the only one. In fact, there could be countless other universes, each with different laws of physics, different forms of matter, and different versions of reality. According to some versions of this theory, our Big Bang might have been just a small bubble that formed in a vast cosmic ocean filled with other bubbles, other universes. Maybe new universes pop into existence all the time, and ours is just one tiny piece of a much bigger picture. All of these theories, inflation, singularity, cyclic universes, and multiverses, try to answer the same big question: where did everything come from? And one of the most interesting tools scientists use to explore this mystery is the strange world of quantum mechanics. Quantum mechanics is the science that explains how things work on the tiniest level, far smaller than atoms. In this realm, particles and energy behave in very strange and unpredictable ways. Things can appear and disappear without warning. One idea from quantum theory is called quantum fluctuations. These are tiny changes in energy that can happen even in what we think of as empty space. Scientists believe that these tiny fluctuations might have helped shape the universe in its very first moments. Here's the fascinating part. If space itself can bubble with energy, then maybe the universe didn't come from nothing after all, at least not in the way we usually think about nothing. Maybe what we call nothing is actually a mysterious field, full of energy and potential, waiting to burst into existence. These small energy bubbles could eventually grow into entire universes, including ours. This idea changes the way we think about creation. It suggests that nothing might not really be empty. Instead, it could be a lively, invisible sea of possibilities, where entire worlds can form from sudden sparks of energy. And it doesn't stop there. These quantum fluctuations may still be happening today, shaping the universe in ways we don't fully understand. Some scientists believe the universe is still slowly expanding because of these changes, and that subtle energy shifts continue to influence the future of everything, from galaxies to atoms. The multiverse theory adds yet another layer to this story. If there are many universes, each one could be shaped by different kinds of quantum fluctuations. Some theories even say that universes can form when two other universes crash into each other. If that's true, then maybe our universe was born not from a single spark, but from a cosmic collision, a kind of universe-making accident in an unimaginably huge space beyond our own. What's more, each of these universes might follow completely different rules. While our universe has certain constants, like the strength of gravity or the speed of light, other universes might have different values for these things. By studying these possibilities, scientists hope to understand how our own universe came to be and what the ingredients for existence really are. Some experts even think the secret to what came before the Big Bang is hiding in these tiny quantum ripples spread across the vastness of the multiverse. By studying how these ripples behave, both in theory and through complex simulations, scientists hope to look backward, through time and beyond, to discover what may have existed before everything began. Finally, we return to the cyclic universe model, one of the oldest and most poetic ideas in all of cosmology. According to this vision, the universe doesn't just have a beginning and an end. Instead, it is eternal, always cycling through life, death, and rebirth. After growing for billions of years, the universe might someday stop expanding and start to shrink. As it collapses, everything is crushed into a dense, hot state, the kind that could lead to a new Big Bang. Then the cycle begins again. One version of this idea is called the oscillating universe model. In this view, the universe goes through endless rhythms of stretching and squeezing, like the breath of some cosmic being. With each new cycle, a new universe is born, carrying echoes of the one that came before. Some theories say that our universe didn't just start from a single event and grow forever. In certain versions of a repeating or cyclical universe, especially ones that are tied to string theory, something amazing might be happening. Instead of the universe growing forever or ending in a frozen dark death, it could be caught in a cosmic loop, expanding, slowing down, shrinking, and then bouncing back to grow again. This cycle could repeat over and over, like breathing in and out, never really starting or ending. This idea is called a cosmic bounce. Rather than the universe collapsing into a single point with infinite heat and density, called a singularity, the process slows down and reverses before reaching that extreme. Then it bounces back and starts a new phase of expansion. In this way, the universe could avoid total destruction and start fresh every time. It's like the phoenix of space, dying in a blaze only to rise again. This kind of thinking goes against the traditional view, which says the universe started with the Big Bang and will either freeze forever or tear itself apart. But if the bounce idea is true, it means the universe could be eternal, going through endless cycles of birth, death, and rebirth, always reshaping itself, creating new worlds out of the remnants of the old ones. Now, to really understand this, we need to go back to the very beginning, right after the Big Bang. One of the most exciting ideas in modern science is cosmic inflation. Imagine a moment when the universe was still smaller than an atom. Then, in less than a trillionth of a second, it expanded faster than the speed of light, growing unimaginably huge in an instant. This rapid stretching helped smooth out the early universe, turning chaotic energy into the orderly cosmos we see today. This inflation happened within the tiniest fraction of a second, but it laid the foundation for everything: galaxies, stars, planets, even life. Thanks to this event, the universe became large, mostly smooth, and ready for matter to form. But what about before inflation? What existed before that sudden burst of growth? This is where things get even more mysterious. Traditional Big Bang theories say that time and space began with the Big Bang, that before it, there was nothing. But inflation theory opens the door to other ideas. Some scientists believe the universe could have come from a different kind of reality entirely, such as a quantum vacuum, a strange field that exists even when there's no matter at all. In this vacuum, tiny fluctuations might have sparked the birth of an entirely new universe. In fact, our universe may not be alone. It might be just one of many, floating in a sea of universes, what scientists call a multiverse. In this multiverse, each universe could have its own laws of physics, its own types of particles, even its own version of time. This leads to a mind-bending idea. Maybe there wasn't a single beginning at all. Maybe time itself is more complicated than we thought. If there's no clear starting point, then what does before even mean? It forces us to ask deep questions, not just about science, but about existence itself. As researchers study cosmic inflation and the strange behavior of the early universe, they aren't just looking for technical answers. They're exploring the nature of reality, how space and time are shaped, and whether the universe is one of many, endlessly evolving. Let's return to the idea of singularities. These are places where the normal laws of physics completely break down. The most famous singularity is the one that supposedly existed at the start of the universe, when all matter and energy were squeezed into one tiny, infinitely dense point. This is what gave rise to the Big Bang about 13.8 billion years ago. Singularities also appear at the heart of black holes, those terrifying cosmic traps from which nothing, not even light, can escape. When a massive star dies, it collapses in on itself and becomes a black hole, with a singularity at its centre. These strange points show up again and again in our attempts to understand how the universe works. Some scientists think that singularities might actually help us understand what happened before the Big Bang, or what might come after the universe ends. For example, if black holes contain singularities, maybe they also hide pathways to new universes, or clues about the fabric of space and time. So these mysterious points are not just where the rules break down, they may also be keys to unlocking the biggest mysteries in the universe. They push us to rethink everything we thought we knew about matter, energy, and the nature of existence. Now let's talk about string theory, one of the most fascinating and complex ideas in modern physics. It says that the tiniest parts of the universe are not particles, like dots or points, but instead are tiny vibrating strings. These strings are so small that we can't see them, but they may be the true building blocks of everything, from atoms to galaxies. Even more amazing, string theory says that there might be extra dimensions, not just the 3 dimensions of space, length, width, and height, and one of time, but 10 or 11 dimensions total. These extra dimensions could be curled up so tightly that we don't notice them, but they might have played a big role in how the universe began. In some versions of string theory, the universe started not from nothing, but from a very different, very dense state, where strings and dimensions dance together in chaos. From that wild state, the Big Bang might have exploded into being, not as a beginning, but as a transition from one form of reality to another. String theory also tries to unite everything we know, the force of gravity, electromagnetism, and the forces inside atoms, into one single theory. That's a big deal. If we could understand how gravity and quantum mechanics fit together, we might finally understand what happened before the Big Bang, and maybe even what happens inside black holes. Right now, string theory is still being debated. Not all scientists agree with it, and it hasn't been proven yet. But it gives us something powerful, a new way to imagine the birth of the universe, not as a single explosion from nowhere, but as part of a bigger, richer, more mysterious reality that goes far beyond anything we can currently see. And we must not forget about dark matter and dark energy, 2 invisible forces that shape the entire universe. Even though we can't see them, they're incredibly important. Dark matter holds galaxies together with its gravity, while dark energy is causing the universe to expand faster and faster. Together, dark matter and dark energy make up about 95% of everything in the universe. That's right. Everything we can see, stars, planets, you, me, is only about 5% of what's out there. Dark matter and dark energy are 2 of the most mysterious and invisible forces in the universe, yet they play a massive role in shaping everything we see in the cosmos. Let's start with dark matter. Scientists believe it makes up about 27% of the entire universe. Even though we can't see it with our eyes or through telescopes, we know it's there because of the way it affects things around it, especially how it pulls on stars and galaxies with its gravity. In fact, dark matter acts like an invisible web, holding galaxies together. Without it, stars would fly apart instead of staying in neat spiral arms, and galaxies wouldn't be able to keep their shape. Everything would just drift away into empty space. This invisible material doesn't shine, reflect, or absorb light, which is why it's called dark. Scientists discovered it not by seeing it directly, but by noticing strange movements of stars and galaxies that couldn't be explained by the matter we can see. Without dark matter, the universe would look completely different, a scattered, chaotic mess, rather than the beautiful and organized structures we see today. On the other hand, there's dark energy, which is even more mysterious. It's believed to make up around 73% of the universe. While dark matter pulls things together with gravity, dark energy does the opposite. It pushes things apart. It's the strange force that causes the universe to expand faster and faster over time. This unexpected acceleration was first discovered in the late 20th century, when astronomers observed distant exploding stars, known as supernovae. These stars were moving away from us more quickly than anyone had expected, and that led scientists to realize that something powerful, something unseen, was driving the universe's expansion. That something was given the name dark energy. Even today, no one truly knows what dark energy is. It defies the rules of gravity as we once understood them, and it forces scientists to rethink everything we thought we knew about space, time, and the universe itself. When you put both dark matter and dark energy together, they make up about 95% of the universe. That means all the planets, stars, galaxies, gas clouds, and people, everything we can actually see, make up only about 5% of the whole cosmos. After the Big Bang, which happened around 13.8 billion years ago, dark matter helped pull regular matter together to form the first stars and galaxies. But as the universe kept expanding, dark energy slowly became stronger than gravity. Over time, it began pushing galaxies farther apart, changing the structure and future of the entire universe. This push and pull between dark matter and dark energy shows us that the cosmos is not just a quiet place of stars drifting in space. It's a dynamic, ever-changing arena where invisible forces are shaping the destiny of everything. And that brings us to a truly mind-blowing idea: the possibility of baby universes. This concept is one of the most fascinating parts of modern cosmology. It comes from scientists' attempts to understand how our universe began, and whether it's the only one out there. The idea of baby universes suggests that our universe might not be alone. Just like a tree might drop seeds to grow new trees, the universe might give birth to smaller, self-contained universes. These baby universes could each have their own versions of physical laws, different from the ones we know. This fits with the idea of cosmic inflation, which says that space expanded incredibly fast right after the Big Bang. During this rapid expansion, it's possible that small pockets of space broke off and began growing into their own independent universes. Some scientists believe that in those first tiny moments after the Big Bang, random fluctuations in energy could have caused certain areas to inflate into new realms. These regions might still be growing, drifting far beyond what we can ever observe, each one becoming a unique universe, like bubbles in a cosmic foam. This gives rise to the idea of a multiverse, a collection of countless universes, all existing side by side but separated from one another by vast distances or even by different dimensions. One especially exciting twist to the baby universe theory comes from quantum mechanics, the branch of physics that deals with the smallest particles and the strangest behaviours in nature. Famous physicist Stephen Hawking once proposed that black holes, the mysterious objects with gravity so strong that not even light can escape, might actually be doorways to new universes. According to this idea, the centre of a black hole, called a singularity, could be a kind of cosmic womb. Instead of just crushing matter into nothingness, it might actually give birth to a new universe on the other side, one with its own stars, galaxies, and possibly even life. From our side, It would look like everything disappeared into the black hole, but from the other side, a brand new universe might be born. As scientists dig deeper into these theories, they're asking some of the biggest questions imaginable. What is the true nature of dark matter and dark energy? Are they just tricks of the equations, or do they point to something even deeper, something we haven't yet discovered? Could baby universes be real? And if so, how many are out there? Each new discovery leads to even more questions, and the more we learn, the more we realize how little we know about the cosmos. Nothing is one of the deepest and most fascinating ideas that philosophers have ever thought about. Imagine a place where there is absolutely nothing. No light, no sound, no air, no time, no space, not even a single speck of dust. That's what nothingness means. The complete absence of anything you can see, touch, feel, or even imagine. It's the total opposite of existence, which is everything we know. Stars, planets, people, thoughts, and emotions. This strange idea, this contrast between nothing and something, makes us ask big, important questions about what reality really is. Why is there something instead of nothing? How can anything exist at all? And what does it truly mean to be? Believe it or not, even in science, especially in a field called quantum mechanics, there's a suggestion that nothing might not be truly empty. Scientists have found that even the emptiest parts of space are actually buzzing with tiny bits of energy. Little particles can suddenly pop into existence and then vanish again in an instant. These strange events hint that even what we call a vacuum, or empty space, might be hiding endless possibilities. This means that even when there's no matter and no energy, the potential for creation might still be there, just waiting. It's like the universe is never truly still. It's always holding the promise of something new, even in the most silent, invisible corners. Thinking about nothingness doesn't just challenge science, it also stirs something deep in the human soul. It makes us reflect on life's value. If nothing was a real thing, then how incredible is it that something exists at all? How lucky are we to live in a universe filled with stars, planets, water, trees, and even the breath in our lungs? Life becomes even more precious when we realize it could have easily been nothing. Even the tiniest particle in your body, every leaf on a tree and every star in the sky becomes a miracle. All these things stand out boldly against the silent, dark background of what could have been. A world without anything. By trying to understand nothingness, we push the limits of what we know. We ask bold questions and explore new ideas. We begin to see that existence is not just about being here. It's about appreciating the constant dance between what is and what could have never been. Philosophers have been wondering about nothingness for thousands of years. In ancient Greece, more than 2,000 years ago, a thinker named Parmenides said that nothing couldn't really exist. According to him, even talking about nothing meant you were giving it a kind of existence. So for Parmenides, only being was real, and non-being or nothing made no sense. Much later, in the 17th century, a French philosopher named René Descartes introduced a new way of thinking. He famously said, "I think, therefore I am." What he meant was that if you can doubt or think, then you must exist. His idea showed that the very act of wondering about nothingness proves you are something. So again, we see this strange tug of war between existence and the idea of nothing. Fast forward to the 20th century, and a group of thinkers called existentialists made nothing a central theme. One of the most famous was Jean-Paul Sartre. He believed that nothingness is deeply connected to our human freedom. According to Sartre, life has no fixed meaning. That can feel scary, but it also gives us a powerful responsibility. Since the universe doesn't hand us a purpose, it's up to us to create one. We have to make our own choices, build our own lives, and find meaning even in the face of emptiness. These deep thoughts about nothing haven't stayed only in philosophy books. They've spilled into science too, especially in questions about how the universe began. Think about this. If we say the universe came from nothing, what kind of nothing was it? Was it really empty? Or was it filled with strange energy and hidden possibilities? Some scientists think that even a vacuum, what we once thought was totally empty, is actually filled with something called quantum fluctuations. These are tiny bursts of energy where particles suddenly appear and then disappear. It's as if the universe has a restless energy, even in places that seem completely still. That's why the word nothing can be so confusing. In science, nothing might still be something after all. If tiny particles can form out of the vacuum, then maybe our entire universe started this way. From a place that looked like nothing but was full of potential. This raises even more questions. If nothing can create something, what rules made that possible? What does it tell us about time, space, and how everything began? These questions don't just belong to science. They touch the heart of philosophy too. Different cultures and schools of thought give different answers. Some say nothing is truly empty. Others say it's just a different kind of being. These ideas shape how scientists build theories, how we think about the Big Bang, and even how we understand life and death. The idea of nothing forces us to look at ourselves and our world in a new way. It's more than just a puzzle, it's a mirror. It reflects our curiosity, our fears, and our endless search for meaning. Philosophers like Jean-Paul Sartre and Martin Heidegger, who lived in the 20th century, believed that facing the idea of nothingness can lead to a deep kind of truth. When we strip away all our illusions, we're left with the raw fact of existence. And in that space we're free to create, to choose, and to make our lives matter. Even in the vast, empty darkness of space, the void is not just absence, it's possibility. It's an open door to everything that might be. That's why, as strange and unsettling as nothing may seem, it is also one of the most powerful ideas we can ever explore. This brings us to the idea of the void. Is nothingness just empty space, a kind of cosmic blank slate? Or does it have hidden qualities we can't yet detect? One famous philosopher, Martin Heidegger, once said that to truly understand what it means to be, we also have to understand what it means not to be. In other words, thinking about nothing helps us make sense of everything. But this also brings up another challenge. How do we talk about something that isn't there? Our words are all built around describing things that exist, not things that don't. Thinking this way also brings up big questions about purpose. If everything around us appeared suddenly, from nothing, was there a reason behind it? Is there some grand plan, or is the universe just a lucky accident? Does life have meaning because we give it meaning, or is there meaning built into the fabric of existence? This puzzle, whether the universe has a reason or is just a random explosion, leads us into deep philosophical territory. It's not just an abstract idea, it affects how we see ourselves, our lives, and our futures. It makes us reflect on whether we are part of a great cosmic story, or simply actors on a stage with no script. Many ancient traditions also have fascinating ideas about what came before the beginning. In Eastern philosophies, especially Hinduism and Buddhism, life is not seen as a straight line but as a circle. In Hindu belief, every person has a soul called Atman, which has lived through countless lifetimes. Your past actions, called karma, shape your present and future. Life is a journey through birth, death, and rebirth, moving toward moksha, a kind of spiritual freedom where the soul becomes one with the divine. Buddhism also speaks of many past lives, but it focuses more on escaping suffering. The goal is enlightenment, a deep realization that sets you free from the cycle of rebirth. In this tradition, people are encouraged to develop compassion and mindfulness, to see themselves as part of a greater whole. In contrast, Western philosophies, especially those shaped by Judaism, Christianity, and ancient Greek and Roman thought, tend to view life as a straight path. In Christianity, for example, it is believed that God creates each soul at the moment of conception. Life is a one-time experience meant to prepare the soul for eternal life after death. Personal identity is closely tied to moral choices and spiritual destiny, not repeated lifetimes. These different worldviews, circular versus linear, rebirth versus one life, lead to very different ideas about what it means to exist and what happens before and after life. But both perspectives ask the same big questions. Who are we? Why are we here? What happens next? Back in the world of modern science, some physicists are also exploring ideas that sound a lot like ancient philosophy. They talk about the universe starting not from a total absence, but from a quantum vacuum. This isn't nothing, as we usually think of it. It's more like a strange kind of energy-filled emptiness, where tiny particles can pop in and out of existence. According to some theories, the entire universe may have burst forth from one of these strange quantum fluctuations, essentially appearing out of almost nothing. This challenges our everyday idea of cause and effect. But if the universe just appeared spontaneously, that neat chain of logic starts to fall apart. It means the rules we live by might not apply to the very beginning of time. This strange possibility, that existence can arise without a cause, has shaken the foundations of science and philosophy alike. It pushes us to imagine a universe where even the laws of physics might not be fixed, but instead emerged with the universe itself. In the vast world of cosmology, scientists often talk about something called the void. This term doesn't just mean a blank space. It refers to huge areas in the universe where there is almost nothing. No stars, no planets, no gas, not even dust. It's a kind of cosmic emptiness, where the absence of matter and energy dominates. Strangely enough, this emptiness is not just empty. It plays an important role in how the universe functions and evolves. This idea of the void is closely connected to what scientists believe the early universe looked like. According to popular theories, just after the Big Bang, the universe was filled with energy and radiation, spread out almost evenly in every direction. At that time, there were no stars, no galaxies, and not even atoms. Matter, as we know it today, had not yet taken shape. In those very first moments, the universe was unimaginably hot and tightly packed. It was in a state so dense that even basic particles like protons and electrons barely existed. But then something amazing happened. The universe began to expand. As it grew larger, it also cooled down, and slowly tiny particles began to form and gather. During this expansion, the void began to grow too. Empty spaces between clumps of matter became larger and more noticeable. But this emptiness wasn't useless or meaningless. It actually played a key part in shaping the universe. The force of gravity pulled matter together in certain places, forming stars, galaxies, and enormous structures that now fill the cosmos. These structures came into being within a background of vast, empty space, the void. So, ironically, it is this emptiness that allowed all the stuff in the universe to come together and create the things we now see. This shows that the void isn't just the absence of something, it's also a crucial part of how the universe works. Without the space between things, there would be no room for stars and galaxies to form. In fact, scientists study these empty regions to better understand mysterious things like dark matter and dark energy, forces and materials we cannot see, but which make up most of the universe. But the void also leads to deeper questions, not just scientific ones, but philosophical ones. When we think about the void, we are also thinking about the strange journey from nothing to something. How did the universe go from being empty to being full of stars, planets, and life? What does it mean for something to exist in the first place? Where does reality begin, and what existed before it? These questions go beyond science. They touch on the heart of human curiosity, our desire to understand not only how things work, but why they exist at all. When we explore the void, we are not only searching through space, we are also exploring our own understanding of existence. We are looking at the tension between what is and what is not, and how everything we see today may have risen out of what once was nothing. This mix of science and philosophy helps us think about the early universe in a more complete way. We begin to see that both the things that exist and the spaces where nothing exists play a part in shaping reality. It helps us ask deeper questions about where we come from, what the universe really is, and how we fit into this vast cosmic picture. And this search for understanding doesn't stop with scientists. All throughout human history, people in different cultures have created stories to explain how the universe began. These stories, often told through myths, legends, and spiritual beliefs, reflect how human beings experience life, especially creation and destruction. In many ancient traditions, the universe was created by gods or powerful forces, and the birth of stars or planets was seen as a symbol of new beginnings. Interestingly, science tells a similar story, but with different tools. Take the death of a star, for example. When a huge star reaches the end of its life, it explodes in a giant event called a supernova. This explosion may seem like pure destruction, but it's actually the beginning of something new. The explosion spreads out elements like carbon, iron, and oxygen, ingredients needed for planets, life, and new stars. So in space, endings are often also beginnings. This balance between destruction and creation is part of how the universe works. The Big Bang, which we now believe was the beginning of everything, can be thought of as a kind of cosmic birth. And the possible future of the universe, whether it ends by collapsing or expanding forever, makes us think of death and renewal. These are ideas we all relate to as human beings. In the very beginning, the universe was a place of unimaginable intensity, a realm of extremes unlike anything we experience today. This earliest phase is known as the Planck era, and it lasted from the exact moment of the Big Bang to about 1/10 million trillion trillionth of a second later. That is from 0 to roughly 10 to the power of minus 43 seconds. During this incredibly tiny sliver of time, the universe was smaller than an atom, hotter than anything we can ever recreate, and packed with more energy than we can even begin to imagine. Everything, space, time, matter, and energy, was squeezed together in a dense, seething cauldron of pure potential. The temperature was estimated to be around 10 octillion degrees Celsius. That's the number 1 followed by 27 zeros. At that point, the 4 fundamental forces we know today, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were not separate. Instead, they were unified into one single mysterious superforce. That means the laws of physics, as we understand them, didn't yet exist in their usual forms. The universe operated under rules that defy our logic, making it incredibly difficult for scientists to describe with our current knowledge. Instead of solid particles like atoms or even protons and neutrons, the universe was filled with a strange, swirling mix of pure energy and radiation. Tiny particles like quarks and electrons were popping in and out of existence, created and destroyed in the blink of an eye. Matter as we know it, everything from stars to people, didn't exist yet. The universe was more like a boiling, glowing soup of pure energy, where the rules of space and time were still taking shape. As this furious environment slowly began to cool, something incredible happened. The once unified force began to separate. This marked the end of the Planck era and the beginning of the next phase, called the Grand Unification Era. During this transition, the different forces started to split apart, and the building blocks of matter slowly began to take form. But the Planck era remains one of the greatest mysteries in science. Even though it lasted for such a tiny moment, it laid the foundation for everything that followed. Understanding what happened during this time could help scientists solve some of the deepest questions about the universe, like how space and time themselves came into being. One of the big challenges is that the normal laws of physics break down at this scale. That's why scientists are searching for a theory of quantum gravity, which would merge Einstein's theory of general relativity, which explains gravity, with quantum mechanics, which explains how tiny particles behave. If such a theory is discovered, it could finally unlock the secrets of the universe's birth. During the Planck epoch, space and time themselves may have behaved in strange and unpredictable ways. Today, we think of time as flowing smoothly, like a river, and space as a stable backdrop with 3 familiar dimensions. But at this microscopic level, time might have ticked forward in little jumps or blinks, not as a smooth stream. Space too might have been so twisted and compact that it's impossible to separate it from time. In fact, the difference between time and space may not have existed at all in the way we understand them now. Physicists believe that at the Planck scale, space-time was not smooth but jittery and foamy, constantly fluctuating due to quantum uncertainty. Picture it not as a calm ocean, but as a bubbling, unpredictable sea. This kind of reality is so alien to us that it challenges even the most advanced scientific minds. As the universe expanded and cooled, the once chaotic space-time began to calm down, and the different forces separated. Space and time became more structured and familiar. This shift opened the door for all the amazing events that would follow, like the formation of atoms, stars, galaxies, and eventually, life. To understand this early chapter of the universe's story, scientists turn to a field known as high-energy physics. This branch of science explores the behavior of particles at energy levels far beyond anything we encounter in our daily lives. Using giant machines like the Large Hadron Collider, researchers smash particles together at nearly the speed of light, recreating conditions similar to those just after the Big Bang. These experiments help scientists understand how particles interact, how the universe's forces behaved when they were still united, and what kinds of matter might have existed in those first flickers of time. High-energy physics also supports theories like cosmic inflation, the idea that right after the Big Bang, the universe expanded faster than the speed of light for a tiny instant. This theory helps explain why the universe today looks so smooth and evenly spread out. By studying particle collisions and the traces they leave behind, scientists can test ideas about how the early universe behaved. They can even explore quantum fluctuations, the tiny wiggles in energy that may have given rise to galaxies billions of years later. But because we can't go back in time or directly observe the Planck era, researchers rely on clever tools like cosmic microwave background radiation, the faint afterglow of the Big Bang, still detectable today. This light, which is over 13 billion years old, contains tiny ripples that offer clues about how matter was distributed in the infant universe. Computer simulations also play a vital role. By using the laws of physics and adjusting various starting conditions, scientists can recreate what might have happened in the first few moments after the Big Bang. These models show how the simplest particles formed, how they combined to make atoms, and eventually how stars and galaxies took shape. Another exciting tool in the quest to understand the early universe is gravitational waves, ripples in space-time caused by powerful cosmic events. If scientists can detect gravitational waves from the earliest times, they could unlock secrets buried in the fabric of the cosmos itself. About 3 minutes after the Big Bang, something extraordinary happened. The universe had cooled enough for quarks to stick together and form protons and neutrons. These particles then began to form the first simple elements, like hydrogen and helium, in a process known as Big Bang nucleosynthesis. This marked the beginning of matter as we know it. In the earliest moments after the birth of the universe, something extraordinary happened. A delicate balance between hydrogen and helium, two of the lightest and most important elements, was set in place. These elements formed in just the first few minutes after the Big Bang and would go on to become the building blocks of everything: stars, galaxies, and even the atoms in our bodies. The amount of each element created during that brief period helped determine how the universe would grow and change. At that time, the universe was still very young, just a few minutes old, but the forces of nature were already hard at work. The temperature was unbelievably high, and matter was packed together incredibly tightly. These two factors, temperature and density, played a powerful role in shaping the future of the cosmos. Where the universe was slightly denser, gravity pulled more matter together. Over billions of years, these dense regions collapsed under their own weight, forming stars, galaxies, and clusters of galaxies. Meanwhile, places with lower density didn't form anything. They simply expanded and cooled, becoming the great empty spaces between galaxies, cosmic voids. By studying how temperature and density behaved back then, scientists today are able to decode a mysterious glow that still fills the universe. This faint light is called the cosmic microwave background radiation, and it is a leftover trace of the Big Bang. It first appeared about 387,000 years after the universe began, when things had cooled enough for atoms to form and light could travel freely through space. Even though this light is extremely weak today, it still carries important clues from that ancient time. When scientists study this radiation, they are not just looking at the past, they are unlocking secrets about the very fabric of our reality. These secrets can be better understood through quantum mechanics, a field of science that explores how the tiniest particles behave in strange and surprising ways. At the quantum level, things don't follow the rules we see in everyday life. Particles can be in many places at once, or exist in several states at the same time until someone observes them. This idea leads to a fascinating question. Before the universe began, could reality itself have been just a swirling sea of possibilities, not a solid, fixed thing, but a cloud of quantum potential waiting to take form? This is where the concept of quantum fluctuations comes in. Even in what seems like complete emptiness, tiny bursts of energy can suddenly appear and disappear. These small bursts might have triggered the birth of the universe itself. Before the Big Bang, there may not have been a universe in the traditional sense. No space, no time, just a bubbling field of quantum energy. It's possible that from this strange and invisible energy, the Big Bang exploded into being. Some bold ideas go even further. The multiverse theory, for example, suggests that our universe is just one among countless others. In this view, there might be an endless number of universes, each with different rules of physics, all existing at the same time. Ours may have just been one of many possible outcomes from a quantum field so vast and rich that it gave birth to many different realities. If this is true, then our understanding of space, time, and even existence itself could be far more complex than we ever imagined. One of the most exciting tools scientists have today to study the early universe is something called gravitational waves. These waves are like ripples in the fabric of space and time, and they carry information from some of the most powerful and violent events in the universe. 100 years ago, Albert Einstein predicted their existence in his theory of general relativity. But it was only in the past few years that scientists finally detected them directly, using extremely sensitive instruments. These gravitational waves may have been created during the universe's first split second, in a moment called cosmic inflation, when space itself expanded faster than the speed of light. By studying the waves left behind from this rapid stretching, researchers can learn what the universe was like when it was just a tiny fraction of a second old. The strength and frequency of these waves might reveal what kinds of energy and forces were at play at the beginning of time. But gravitational waves don't just come from the early universe, they also come from dramatic events like the collisions of black holes and neutron stars. These cosmic smash-ups send ripples through space that we can now detect, giving us a brand new way to explore the universe. Each new discovery brings us closer to understanding how stars and galaxies formed, how gravity works, and how the universe has changed over time. Gravitational wave science is still young, but it is already transforming the way we see the cosmos. As scientists continue to improve their tools and theories, they may uncover even deeper secrets, perhaps even what happened before the universe as we know it came into being. This is a thrilling new chapter in our quest to understand everything around us. And all of this connects back to that dim, ancient glow, the cosmic background radiation. That gentle light, which appeared nearly 400,000 years after the Big Bang, is a snapshot of a universe that was just starting to take shape. At that moment, the hot plasma cooled enough for atoms to form, and for the first time, light could move freely through space. This light still shines today, faint and cold, but full of information. When scientists map this radiation, they find tiny differences, little spots that are slightly warmer or cooler. These differences show where matter was beginning to clump together and where it was spreading out. From this, we can tell that the early universe wasn't perfectly smooth. It had just enough irregularity to create all the stars and galaxies we see today. Some of the most fascinating theories in modern science, like string theory and the idea of a multiverse, suggest that our universe might not be the only one. In fact, there could be countless other universes, each with its own laws of physics. This opens up a mind-boggling possibility. Maybe the question of what happened before the Big Bang doesn't even make sense in the usual way we think about time. In such models, the Big Bang might not have been the beginning of everything, just the start of our universe's story. To explore this great cosmic mystery, scientists are studying the faint glow that still lingers from the early universe, the cosmic microwave background radiation. This glow, which has been travelling across the cosmos for almost 14 billion years, is like a fingerprint left behind from the universe's first moments. By carefully examining its patterns, scientists are slowly piecing together a picture of what the early universe looked like. Every new discovery brings us a little closer to answering ancient questions that humans have been asking for thousands of years. Where did we come from? What started it all? Why does the universe look the way it does? Thanks to amazing technological advances, researchers now have tools that can measure the universe with incredible precision. These tools are helping them uncover details about the universe's childhood, and maybe even hints about what, if anything, existed before that moment of first light. One major focus is the study of the cosmic microwave background, the afterglow of the Big Bang. By analysing tiny temperature differences in this radiation, scientists can learn about how matter was spread out in the early universe. These measurements are helping test a powerful idea known as inflationary theory. This theory suggests that, in the blink of an eye after the Big Bang, the universe went through a sudden, unbelievable expansion, faster than the speed of light. This rapid growth could explain why the universe looks so smooth and evenly spread out today. But that's not the only path scientists are exploring. In the world of particle physics, scientists are using the Large Hadron Collider, the most powerful particle accelerator on Earth. This incredible machine, located underground in Europe, smashes tiny particles together at nearly the speed of light. These collisions recreate the super hot, super dense conditions that existed just a tiny fraction of a second after the Big Bang. By watching how the tiniest building blocks of matter behave in these extreme conditions, physicists hope to unlock the secrets of how the universe began. If they find new particles or new forces, it could completely change what we think we know. Another exciting field is gravitational wave astronomy. In the year 2015, scientists made history by detecting gravitational waves for the very first time. Tiny ripples in space-time caused by massive cosmic events like black hole collisions. This discovery opened a whole new way of observing the universe. Now, by tracking these waves, scientists can peek into events that happened very early in the universe's timeline, possibly even before light itself could travel freely through space. Gravitational waves give us a completely different way of looking at the universe's birth and early growth. Scientists believed that time and space were fixed and unchanging. This way of thinking, known as classical physics, reached its highest point with the famous scientist Sir Isaac Newton. According to Newton, time ticked away steadily for everyone, no matter how fast they were moving or where they were. He also saw space as a giant, unmoving stage where all events took place, like a theatre that never changed, while the actors, planets, stars, people, moved across it. This idea worked well for many situations, especially the kinds of things we deal with in daily life, like falling apples or moving trains. But as science progressed and the 20th century drew near, people started to notice that Newton's rules didn't work so well when things got really fast, close to the speed of light, or when they involved very strong gravity. Then came a man named Albert Einstein, who would change everything. In the year 1905, he introduced something called the theory of special relativity. It was a brand new way of looking at the universe. Einstein said that space and time were not two separate things. They were actually part of one single connected fabric called space-time. This meant that time didn't flow the same for everyone. Instead, how fast or slow time seemed to pass could depend on how fast someone was moving. For example, someone travelling in a spaceship near the speed of light would actually age more slowly than someone who stayed on Earth. This strange idea was captured in a famous thought experiment involving two twins. One goes on a space journey at high speed, while the other stays home. When the space-travelling twin comes back, they're younger than their sibling. Einstein didn't stop there. In the year 1915, he introduced another major idea called general relativity. This expanded his earlier theory to include gravity. He explained that massive things, like planets, stars, and black holes, actually bend the fabric of space-time around them. This bending affects how time passes and even how light moves. For instance, time runs a little bit slower near Earth's surface, where gravity is stronger, than it does far above in space. Scientists have tested this using super-precise atomic clocks, and it turns out to be true. This shift from classical physics to modern physics completely changed how we see the universe. Space was no longer just an empty box, and time was no longer a universal clock ticking the same for everyone. Instead, space and time became living parts of the cosmos, always interacting and changing depending on motion and gravity. Einstein's discoveries didn't just help us understand the universe, they also led to real-life inventions. For example, technologies like GPS, Global Positioning System, which help you find your way with a phone or a car, actually depend on Einstein's ideas. Without accounting for the way time flows differently for satellites in orbit, GPS systems would give inaccurate results. But Einstein's theory also opened the door to even deeper questions. especially about the beginning of everything, the Big Bang. Scientists once thought of time as a straight line, where events happen one after another, starting from a clear beginning. But now there are new ideas that challenge this simple picture. Some scientists talk about nonlinear time. This means time might not flow in a straight line at all. Instead, events could be connected in strange ways, looping back or even happening out of order. It's possible that the past, present and future could influence each other all at once, in ways we don't yet fully understand. This idea becomes especially interesting when we try to imagine what happened before the Big Bang. If the universe started with a huge explosion from an extremely tiny and dense point, what scientists call a singularity, then maybe time itself didn't even exist before that moment. Or maybe time existed in a way that's very different from what we're used to, like a shifting web instead of a straight path. In this way of thinking, the beginning of the universe wasn't just a starting point, but more like a transformation. Some theories even suggest there could be multiple universes, or that the universe goes through cycles with no true beginning or end, only endless change. This also changes how we think about cause and effect. If time isn't strictly linear, then the future might influence the past, just as the past influences the future. It's a wild idea, but it helps scientists and philosophers ask new questions about what existence really means. When we look deep into space, or into the depths of black holes where gravity is extremely strong, our normal ideas about time begin to fall apart. Time might stretch, twist, or even stop altogether in these extreme places. That's why a nonlinear model of time might help explain what's going on in situations where the usual rules no longer apply. The ideas behind the theory of relativity go far beyond just physics and equations. They touch on some of the deepest questions we can ask about the universe. They invite us to think about where everything came from, what life and existence really mean, and what reality itself truly is. One of the most puzzling and fascinating questions is whether time can exist on its own, without space. This is not just a simple idea, it reaches into the very heart of how we understand the universe. In everyday life, we think of time and space as separate things. But in the early 20th century, a brilliant scientist named Albert Einstein changed that view forever with his theory of general relativity. According to this theory, time and space are not two different things. They are parts of a single, united whole called space-time. This space-time is like a four-dimensional fabric that makes up the very structure of the universe. There are 3 dimensions of space: length, width, and height. And time is the 4th dimension. In this view, time is tightly woven into space. You cannot change one without affecting the other. However, not all theories see it that way. In some versions of quantum physics, time might be something more basic than space. Some scientists have even wondered, what if time existed before space? What if time was already ticking before the universe began? This strange but fascinating idea leads us into the mystery of how the universe began. If time already existed before space, it might mean that events were already happening, even before the Big Bang. The Big Bang is the scientific name for the moment when everything in our universe began. According to this theory, the universe started about 13.8 billion years ago, when all of space, time, matter, and energy exploded into being from an unimaginably hot and dense point. That moment marked the beginning of both time and space as we know them. But what if something came before it? What if time stretched back beyond that moment? That would mean reality is far more mysterious than we ever imagined. It could mean that the idea of cause and effect, where one thing leads to another, might not have worked the same way back then. Trying to picture such a reality is incredibly hard for our minds, which are used to living in a world where time always moves forward and space surrounds us. Still, thinking about these big ideas can help us better understand how everything began. Can we even imagine a time without space? What does time mean when there are no stars, no planets, not even empty space, just something else? These questions are like windows into the unknown, pushing the boundaries of science and philosophy. They make us wonder not just how the universe began, but why it began, and what it really means to exist. The Big Bang Theory tells us that about 13.8 billion years ago, the universe began in a sudden burst of heat, light, and energy. But it wasn't just matter and energy that were born in that instant. Time and space themselves came into being. Before that moment, our usual ideas of before and after might not have made any sense at all, because time, as we understand it, didn't exist yet. Everything we know, space, time, stars, galaxies, even the atoms in our bodies, came from that first moment. As the universe expanded, it began to cool down. In that cooling process, tiny particles started to form. Those particles eventually joined together to make atoms. Over billions of years, those atoms grouped into stars and galaxies. In this way, the flow of time became connected to the way the universe grew and changed. Time became like a thread running through everything, from the tiniest particles to the largest galaxies. Every moment in the history of the universe became a step in this unfolding cosmic journey. Albert Einstein's theory of general relativity also tells us something even more amazing. It says that mass and energy can actually bend the fabric of space-time. That means objects like stars and planets can curve space and slow down time. So when the universe expands, it isn't just matter flying through space, it's space itself that is stretching. And because time is part of space, time stretches too. It's as if the entire universe is a giant balloon that keeps growing, and time is part of the rubber that makes up that balloon. Scientists have also explored what quantum physics says about the beginning of the universe. Quantum physics is the science of the very small, the strange, unpredictable world of particles and energy. Some theories suggest that tiny random changes in energy, called quantum fluctuations, might have started the Big Bang. This leads to wild and exciting ideas, like the possibility that our universe is just one of many, a small part of a much bigger multiverse, where countless other universes might also exist. If these ideas are true, then the Big Bang wasn't just the start of our universe. It might have been just one moment in an endless series of cosmic events. This makes us ask even deeper questions. What is reality? Is time something that stretches forever? Or did it truly begin with the Big Bang? Could there be other types of time, or even places where time flows differently? Time plays a huge role in how we understand the universe. When we look at faraway galaxies, we're also looking into the past. Because light takes time to travel, we see those galaxies as they were billions of years ago. This means time is like a cosmic time machine, showing us what the universe used to look like. Scientists use this light to measure how fast the universe is expanding. This is called Hubble's law, and it shows that the farther away a galaxy is, the faster it is moving away from us. By studying this expansion, scientists can figure out the age of the universe. They look at how much the light from distant galaxies has been stretched, a process called redshift, to measure how long the universe has been growing. This helps them understand how stars, galaxies, and planets have formed over billions of years. The light we see today from the farthest galaxies began its journey billions of years ago, giving us a glimpse into the ancient past. Einstein's relativity also changed how we think about time itself. It showed that time does not flow the same for everyone. Time can move slower near something with a lot of gravity, like a black hole, or for someone travelling very fast, close to the speed of light. This means that time is not fixed. It can bend, stretch, and twist depending on where you are and how fast you're moving. Because of this, the way we understand the universe's expansion becomes more complicated. Time might behave differently in different parts of the universe. Loop quantum gravity offers an exciting and bold new way to think about the universe, especially when we start wondering what might have happened before the Big Bang. This theory doesn't just build on what we already know, it dares to question the very foundation of how we understand space and time. For a long time, scientists pictured space and time as smooth and continuous, like a calm sheet of fabric stretching endlessly in all directions. But loop quantum gravity suggests something very different. Instead of being one seamless flow, space and time might actually be made up of tiny separate pieces, almost like the individual threads of a vast cosmic tapestry. Imagine that instead of being smooth and unbroken, space is built from countless little loops, each one twisting and turning, connecting with others, forming a huge invisible web that holds the universe together. These loops are incredibly small, far smaller than anything we can see, but together they form the basic structure of everything that exists. Now, let's travel back in our imagination, not just millions or billions of years, but all the way to the very beginning of time itself. Most people are familiar with the Big Bang theory, which says the universe began about 13.8 billion years ago with a massive explosion from a single point, called a singularity. But loop quantum gravity tells a different, more mysterious story. According to this theory, there might never have been a singularity at all. Instead, what we call the Big Bang could have been a kind of bounce, a transition from an earlier phase of the universe. In other words, before our universe began expanding, there might have been a completely different universe collapsing in on itself. And when that universe reached a certain point, it didn't end. It bounced, giving birth to our universe. This suggests something truly incredible. Time might not be a straight line with a beginning and an end. It could be more like a circle, with no clear start or finish, just endless cycles of birth, death, and rebirth on a cosmic scale. In this picture, the universe doesn't just begin once and move forward forever. It transforms again and again, shaped by deep and complex quantum processes. Near the moment of the Big Bang, when everything was squeezed into a state of unimaginable density, the normal rules of physics break down. Gravity no longer behaves the way we're used to. Space and time begin to blur. In these extreme conditions, loop quantum gravity allows us to imagine a reality where the universe doesn't just spring from nothing, but from something else entirely, something governed by the strange and powerful laws of quantum gravity. This theory also changes the way we think about existence itself. If space and time are built from tiny units, if they're quantized, as physicists say, then everything we know, from galaxies to particles, rests on a structure far more intricate and mysterious than we ever imagined. It means we may need to rethink not only the beginning of the universe, but the very fabric of reality. The questions raised by loop quantum gravity aren't just scientific, they're deeply philosophical too. Human beings have long thought about time. Some see it as a river that flows from the past through the present into the future. Others, like the great philosopher Immanuel Kant, believed that time might actually be something that lives inside our minds, a way for our brains to make sense of the world around us. This raises some fascinating questions. Does time exist by itself, out there in the universe? Or is it something we create with our minds as we try to understand our place in the cosmos? Science and philosophy come together at this point. The question of what happened before the Big Bang ties directly into our deepest ideas about what time really is. According to traditional scientific views, time began with the Big Bang about 13.8 billion years ago. So when we ask what came before that, we're asking something that may not even make sense in the usual way. If there was no time before the Big Bang, then before might not exist at all. But some scientists believe there might be more to the story. New theories, like loop quantum gravity, quantum cosmology, and the idea of a multiverse, suggest that our universe might be just one of many, or that time might behave in strange non-linear ways we can barely imagine. All of this brings us back to a question as old as humanity itself. Can we ever truly understand the beginning of everything? Or are our minds simply not built to grasp such vast, complex truths? As scientists study the universe's earliest moments using mathematics and advanced technology, philosophers continue to explore the same questions through deep thought and reflection. The story of how the universe began is not just something scientists talk about in labs or observatories. It touches something deep within all of us. Across time and around the world, people have always wondered where everything came from. This curiosity has shaped not just science, but also religion, philosophy, and culture. For thousands of years, humans have looked up at the stars and created stories about the sky. These stories became the heart of many ancient traditions, forming the foundations of belief systems that helped people make sense of life, death, and their place in the grand scheme of things. Long before modern science, ancient civilizations crafted beautiful myths about the beginning of the universe. These tales weren't just entertainment, they carried deep meanings about how to live, how to treat others, and how to understand the world. In many religious traditions, the universe was not just created, it was created for a reason. For example, in the Jewish and Christian faiths, the book of Genesis tells of a single, all-powerful God who created the heavens and the earth with purpose and care. This story brings comfort and a sense of order, encouraging kindness, justice, and community spirit. In Hinduism, the view of the cosmos is even more expansive. Instead of a one-time creation, Hindu cosmology describes an endless cycle of creation, destruction, and rebirth. The universe is seen as a vast rhythm, where time flows like a river, constantly renewing itself. This belief shapes how followers understand life, death, and the divine, offering a peaceful acceptance of change and a sense of harmony with the universe. These spiritual and cultural interpretations of the universe's beginnings give people a framework for living. They help explain life's mysteries, offer comfort in times of confusion, and guide moral values. Even in today's fast-paced, technology-driven world, these ancient ideas still echo in our hearts. But in the last few centuries, especially since the early 20th century, science has stepped in with new ideas about the birth of the cosmos. One of the most powerful scientific theories is called the Big Bang. According to this idea, the universe began around 13.8 billion years ago as an unimaginably small, hot, and dense point, which suddenly expanded and has been growing ever since. This theory is backed by powerful evidence, like the faint glow of ancient light still visible in space and the way galaxies are moving apart. Although the Big Bang is a scientific concept, it stirs emotions and deep questions just like the old myths did. Some people feel awe and wonder at the vastness and complexity of the universe. Others feel a bit unsettled, especially if these ideas seem to challenge their spiritual beliefs. For many, though, the scientific and the spiritual can live side by side, each offering its own kind of insight and inspiration. As technology improves, through space telescopes, satellites, and powerful computers, we are peering deeper into the universe than ever before. Each new discovery brings us closer to understanding where we came from. But these discoveries also lead to new mysteries. The more we know, the more we realize how much we still don't know. Our growing knowledge doesn't just change science books, it can also change how we see ourselves. Learning that Earth is just a tiny dot in an enormous universe can make us feel small, but it can also remind us how connected everything is. If we someday discover life beyond our planet, it could completely change the way we think about life here on Earth. It might unite humanity in a shared sense of wonder, encouraging us to treat each other and our planet with more care. Cosmology, the study of the universe, has the power to shift our entire worldview. It can change how we think about time, space, and reality itself. Ideas like the multiverse, the idea that there may be many universes, or the possibility of dimensions beyond the ones we can see, invite us to rethink things like fate, choice, and what it means to be alive. Suddenly, traditional ways of thinking may no longer be enough. New philosophies emerge, blending old wisdom with new discoveries. And at the center of all this is storytelling. For as long as humans have existed, we have used stories to understand the unknown. Storytelling turns strange and complicated ideas into something familiar and personal. It helps us picture the invisible, feel the unimaginable, and make sense of the impossible. When we tell stories about the cosmos, whether they come from ancient legends or modern science, we are trying to connect with something bigger than ourselves. Many old myths explain the stars and planets through magical tales. Some cultures believed the stars were ancestors watching over us, while others saw them as gods or spirits. These stories filled people with wonder, and they passed them down through generations. Even today, we still look to the skies and ask the same questions. Where do we come from? What is out there? What does it mean to be human? Science, too, uses stories. When scientists talk about things like black holes, dark matter, or the origins of the universe, they often use narratives to make these ideas easier to understand. They tell the story of how the universe began, what it went through, and where it might be heading. This way of sharing science helps people connect to it. It invites everyone to join the journey of discovery, turning abstract facts into meaningful ideas. Through storytelling, whether it comes from myth or science, we explore our fears and hopes. We try to understand what life means and how we fit into the universe. We take vast, distant, confusing things and bring them close to our hearts. In this way, storytelling is more than a way to pass the time. It is a powerful tool that helps us ask deep questions, share big ideas, and find meaning in the chaos. It helps us navigate the darkness by lighting a path with imagination and understanding. As science continues to reveal more about the cosmos, our view of the world may keep shifting. Discoveries like black holes, strange places where not even light can escape, or the possibility of other dimensions make us question everything we thought we knew. But they also invite us to dream bigger. They encourage us to see ourselves not just as individuals or even citizens of Earth, but as part of a much grander story. Throughout history, cultures across the world have told stories about how the universe began, and how it might someday end. Ancient people often looked to the stars to understand the patterns of life. Many indigenous cultures in North America, for example, speak of great spirits or clever tricksters who shaped the world. Unlike modern science, which tends to explain the universe with mathematics and physical laws, ancient cultures often used rich stories and powerful symbols to understand how everything began. One fascinating example comes from ancient Egypt. In their creation myths, the universe started as a vast, dark ocean known as the primordial waters. Out of this mysterious sea rose a god named Atum, who stood all alone on a small mound. From himself, Atum created the first gods, beginning a chain of events that would lead to the formation of the world and all living things. For the ancient Egyptians, creation was not just something that happened once. It was something that kept happening again and again. They believed this cycle could be seen in the daily journey of the sun god Ra, who sailed across the sky each day, bringing light and life, and then descended into the underworld each night, only to rise again the next morning. This never-ending rhythm symbolized the endless flow of life, death, and rebirth. In a similar way, Hindu cosmology also paints a picture of time not as a straight line with a beginning and an end, but as a vast circle. In this view, the entire universe is constantly being created, preserved, and destroyed, only to be born again. It's like an eternal dance between the forces of creation and destruction, carried out by powerful gods like Brahma the creator, Vishnu the preserver, and Shiva the destroyer. This idea suggests that nothing truly ends. Everything changes, transforms, and returns in a new form. These ancient views were not only meant to explain where the world came from, but also to help people deal with some of life's biggest questions, like the fear of death, the search for purpose, and the mysteries of what comes after life ends. Even today, many spiritual traditions still carry these ideas. For example, in Christianity, believers look forward to the apocalypse, a final, dramatic moment of judgment and renewal. In Islam, there is the Day of Judgment, when all souls will be called to account. Both of these beliefs suggest that history is moving toward a meaningful conclusion, and that how we live our lives today matters deeply. These stories are filled with moral teachings that guide how people should behave and help them think about right and wrong. Surprisingly, modern science is beginning to echo some of these ancient themes. The Big Bang theory, which suggests that the universe began from a tiny, incredibly dense point around 13.8 billion years ago, tells a story of sudden creation not so different from some ancient myths. Scientists also believe the universe may one day come to an end, perhaps through a slow and cold fading called the heat death, or a dramatic reversal called the Big Crunch, where everything collapses back in on itself. These scientific possibilities remind us that even the universe might have a beginning and an end, just like the ancient people believed. There is a fascinating meeting point between science and culture here, a kind of ongoing conversation between what we can observe through telescopes and what we imagine in our stories and philosophies. This dialogue shows that, whether through religious beliefs or scientific theories, humans everywhere are trying to answer the same big questions. Where did we come from? Why are we here? And what will become of us? One of the most mind-bending ideas from modern science is the possibility of a multiverse. That is, the idea that our universe might be just one of many, possibly an infinite number, each with its own laws of nature, histories, and versions of reality. If this is true, then there might be countless other versions of each one of us, living different lives, making different choices, and facing different outcomes. Some of these versions might be nearly identical to us, while others could be completely unrecognizable. This strange possibility forces us to ask deep questions about who we are. Are we defined by the choices we make, or is there something more essential and unchanging at our core? If every possible version of our lives is playing out somewhere in the multiverse, does that make our decisions less important, or even more so because each choice creates a whole new reality? These thoughts can be unsettling. Some people might feel that if every possibility exists somewhere, then their own life loses meaning. But others find it exciting, even comforting. If every choice leads to a new story, then every experience becomes precious, each one part of a vast and colourful pattern of existence. In this way, the idea of a multiverse doesn't just change how we see the universe, it changes how we see ourselves. Thinking about other versions of ourselves also raises questions about responsibility and free will. If another version of you made a very different decision, who is truly accountable? You or that other you? Are we just the result of random events and conditions, or do we have the power to shape our paths no matter the universe? These are questions that philosophers have wrestled with for thousands of years. Now, science adds new fuel to that age-old fire. However, the idea of the multiverse opens the door to incredible possibilities. It connects science with philosophy, creating a bridge between cold facts and deep meaning. It invites us to explore not just the outer universe, but our inner selves, to ask what it really means to be us in a world that may be infinitely more complex than we ever imagined. At the same time, scientific discoveries about how the universe began often spark meaningful conversations that touch on spiritual and religious ideas. When scientists talk about the Big Bang or describe how stars and galaxies formed, they are telling a story of the cosmos that can stir a sense of awe, just like ancient myths did. Many people, when they hear that all of existence might have come from a single point of energy, are reminded of sacred stories where a divine being creates order out of chaos. For many spiritual traditions, creation began with a powerful act or a sacred moment, a kind of divine explosion, so to speak. And science, too, talks about a moment of tremendous energy at the beginning of time. These similarities have led many to believe that science and spirituality do not need to be in conflict. Instead, they can support each other, each offering different kinds of insight about the same mysteries. Discoveries like cosmic microwave background radiation, the faint afterglow of the Big Bang, or the observation that galaxies are moving away from each other, leading to the idea of an expanding universe, raise questions that go far beyond mathematics. They make us wonder, why are we here? Is there a reason for it all? What does it mean to be part of such a vast, beautiful and mysterious cosmos? When science and spirituality come together in these moments of reflection, they can create a deep respect between two ways of knowing. One relies on data and experiments, the other relies on faith, meaning, and inner experience, but both are part of the human journey to understand who we are and what our place is in this universe. Helping people understand these big ideas is an important job, and this is where schools and universities come in. Educational institutions play a huge role in taking these complex scientific ideas and making them understandable for everyone. In universities, students can study cosmology, the science of how the universe began and how it works. These courses teach students to think deeply and critically, and they often explore challenging topics like dark matter, which we cannot see but know is there, or cosmic inflation, a period when the universe expanded faster than the speed of light right after the Big Bang. But education doesn't stop in the classroom. Many universities also reach out to the public. They host open lectures, run science festivals, and hold events in planetariums. At these gatherings, leading scientists often share their latest discoveries in ways that regular people can understand and enjoy. The goal is to spread knowledge, but also to inspire curiosity, wonder, and imagination. Some research centres even invite people from the community to join in their work through citizen science programs. These projects let everyday people help track comets, observe the stars, or analyse data from telescopes. This kind of involvement helps people feel more connected to the universe and to the science that explores it. And more recently, universities have started paying attention to the ethical and philosophical questions that cosmology raises. Questions like, should we change the future of the universe if we could? What responsibilities do we have, knowing that we live in a tiny part of something unimaginably vast? In recent years, there has been a growing interest in schools and universities in talking not just about space discoveries and technology, but also about how these amazing advances affect our lives and responsibilities here on Earth. This way of thinking, looking at the bigger picture, helps ensure that as we reach for the stars, we don't forget to look inward and ask deep questions about what it all means for humanity. By including these powerful ideas in education, schools are helping to shape a new generation that doesn't just know facts about the universe, but also feels connected to the larger story of existence. These students are encouraged to think not only like scientists, but also like dreamers, visionaries, and caretakers of the planet. At the same time, there is a fascinating relationship between science and storytelling. Science fiction and futurism, those imaginative stories about time travel, alien worlds, and artificial intelligence, often grow from real scientific theories. They reflect our curiosity and fears, our hopes and dreams. These stories don't just echo scientific ideas, they also stretch them, twist them, and bring them to life in ways that inspire both scientists and ordinary people to imagine what might be possible. As science moved forward, especially during the fields of physics and cosmology in the 20th century, storytellers began weaving these new discoveries into their tales. For example, in the early part of the 20th century when Albert Einstein introduced his theory of relativity, people started thinking about time and space in totally new ways. Time was no longer just a ticking clock. It became something flexible, something that could be bent and stretched. This mind-blowing idea gave birth to a wave of creative stories. One of the most famous early examples is the novel The Time Machine by H.G. Wells, written in the year 1895. In this story, Wells described time as a fourth dimension, something that could be travelled through just like distance. This idea captured the imagination of millions and planted the seeds for many more stories to come. It also inspired scientists and thinkers to wonder, if we can move through space, could we one day travel through time too? As the decades rolled on, especially from the second half of the 20th century onward, even more strange and exciting ideas emerged. Theories like quantum mechanics and the possibility of multiple universes, what some call the multiverse, began to appear. These theories suggested that reality might not be as solid or simple as we once thought. Instead, there could be many different versions of reality, with countless parallel worlds, each one slightly different from ours. Writers like Philip K. Dick explored these ideas with brilliant imagination. His stories asked questions like, what if everything we think is real is actually fake? What if we're living in a simulation? These ideas may sound far-fetched, but they made people think more deeply about what it really means to be alive and aware. Later, movies like The Matrix, released in the year 1999, turned these ideas into unforgettable stories, combining science, action, and philosophy in a way that captured the minds of millions around the world. These stories did more than entertain. They made people wonder about the nature of consciousness, about whether we have free will, and about the true shape of the universe. They helped bring complicated scientific theories to life, making them easier to understand and more exciting to think about. Today, in the 21st century, new scientific breakthroughs are sparking even more fascinating stories. Discoveries in artificial intelligence, space travel, and genetic engineering are being turned into books, films, and games that explore what the future might look like. These stories imagine both the wonders and the dangers of tomorrow. At the same time, science fiction continues to influence the way people think about real science. It inspires curiosity, and sometimes even pushes scientists to turn fiction into reality. In this way, science and storytelling are in a kind of dance. One inspires the other, and together they keep our imaginations alive. Every time we make a new discovery, we also create a new story, a new vision of what might be possible, and those visions help shape how we think about ourselves, our planet, and the vast universe beyond. One especially powerful idea that has come from both science and storytelling is the concept of the cyclical universe. For a long time, many people thought of life as a straight line. We are born, we live, and then we die. The universe too was thought to have a beginning, the Big Bang, and eventually an end. But modern theories suggest something quite different. Some scientists now believe the universe may go through endless cycles of birth, death, and rebirth. In these models, the universe is not a one-time event. Instead, it expands, cools, and forms stars and galaxies, only to collapse again into a tiny dense point. From that point, it might explode outward once more, starting a brand new cycle. This means that the universe might not have just one story, but many stories, playing out again and again across the ages. Understanding how the universe began is one of the deepest and most fascinating questions humanity has ever asked. To explore this mystery, we turn to two powerful ways of thinking: science and philosophy. Each of these paths offers a unique perspective, and when they come together, they help us see the bigger picture in ways we might never have imagined. On one hand, empirical science focuses on facts that can be seen, measured, and tested. Scientists gather evidence through careful observations, complex experiments, and advanced technologies. In fields like astrophysics and cosmology, researchers study incredible things, such as the faint glow left over from the early universe, known as cosmic microwave background radiation, and the way galaxies are moving apart, which shows that the universe is still expanding. These findings help scientists build detailed models of how everything began and evolved over time. One of the most widely accepted scientific models is the Big Bang theory. According to this idea, the universe started from an unimaginably hot and dense point, about 13.8 billion years ago, and has been expanding ever since. This theory isn't just based on guesses, it's supported by real data, like the stretching of light from distant galaxies and the traces of energy left from the universe's early moments. But science doesn't have all the answers. Some questions are just too big, too abstract, or too mysterious to be answered by experiments alone. That's where philosophy steps in. Philosophical inquiry digs deeper into the meaning behind the facts. Philosophers ask questions that go beyond what science can observe directly. They wonder about ideas like existence, causality, and the true nature of time. For example, did the universe really have a beginning? Or has it always existed in some form? What does it even mean for something to begin? If time itself began with the Big Bang, then how can there be a before? These are not just abstract riddles. They're important because they help scientists think in new ways. Throughout history, philosophy has pushed science to explore new ideas. For example, the concept of multiple universes, or multiverses, comes from scientific theories but raises huge philosophical questions. If other universes exist alongside our own, what does that say about our understanding of reality? Are we just one small piece of something much larger and stranger? The relationship between science and philosophy is a two-way street. Scientific discoveries often lead to new philosophical questions, and philosophical ideas can spark fresh scientific investigations. Together, they form a powerful partnership that helps us dig deeper into the mysteries of the cosmos. Take the question of causality, the idea that everything must have a cause. In everyday life, this makes sense. But when scientists explore what came before the Big Bang, things get tricky. Does the universe itself need a cause? Could it exist without one? This question shakes the foundations of both science and philosophy, challenging our assumptions and inviting new ways of thinking. Great thinkers like Immanuel Kant, a German philosopher from the 18th century, suggested that our understanding of time might just be a human-made idea, a way our minds organize experiences. If that's true, then time might not exist in the way we usually imagine. This kind of thinking opens the door to bold new scientific theories about what the universe might have looked like before the Big Bang, or whether before even makes sense at all. Sometimes, scientific theories get so abstract, like those involving quantum cosmology or the multiverse, that they seem to go beyond what we can truly understand. This is when philosophy becomes especially important. It helps scientists think about the limits of human knowledge and whether there are things we might never fully grasp. Different cosmological theories, such as the Big Bang model and the steady-state theory, show how science and philosophy often work together, even when they disagree. The steady-state theory, for instance, once claimed that the universe had no beginning at all but was constantly creating new matter to keep its appearance unchanged. While this theory is no longer widely accepted, it highlights how philosophical ideas can shape scientific thought and challenge mainstream beliefs. New discoveries continue to shake up what we know. For example, scientists have found that most of the universe is made of mysterious things called dark matter and dark energy, stuff we can't see, but that makes up most of reality. This has not only led to new scientific research, but also deep philosophical questions. What is reality made of? Can we ever understand things we can't observe directly? As our telescopes and space missions become more advanced, we're able to look deeper into space and further back in time. This new information often changes how we think about everything, forcing scientists and philosophers to revisit old questions with fresh perspectives. Even when scientific theories fail, they can still be incredibly useful. In fact, some of the most exciting breakthroughs in history have come from moments when old ideas didn't work anymore. Trying to imagine what existed before the Big Bang has led scientists to rethink how time and space work, and what the laws of physics really mean. These failures push science forward and invite more philosophical reflection. Most traditional scientific models imagine time as something that flows in a straight line, from past to present to future. But things become much more puzzling when we consider that time itself might have actually begun with the event we call the Big Bang. If time started at that point, then what does it even mean to talk about anything that happened before it? It's like asking what's north of the North Pole. It simply doesn't make sense in the usual way we think. This strange and fascinating puzzle has led many scientists and thinkers to explore bold new ideas. Some have proposed that the universe might not have started just once, but could go through endless cycles of birth, death, and rebirth, like a cosmic loop. Others have turned to the world of quantum physics, which deals with the tiniest particles and strange probabilities, to imagine what might have existed, or not existed at the very beginning. One area of particular interest is something called quantum fluctuations. These are tiny, unpredictable changes in energy that happen all the time in empty space. Some scientists believe that these strange little tremors could have helped trigger the rapid expansion of the universe in its earliest moments, a period known as inflation. But trying to build accurate models of how this worked has proven difficult. It's hard to explain exactly how these random events could have produced the energy and matter we see today. These difficulties show us that our understanding is still incomplete, but they also open the door to amazing new possibilities. Some of these new ideas include the possibility that our universe might be just one of many. In other words, we might live in a multiverse, a vast collection of parallel worlds, each with its own rules, dimensions, and even different versions of reality. Some theories even suggest there could be hidden dimensions that we can't perceive with our senses or current technology. Exploring these ideas isn't just about understanding how our universe began, it's also about asking deeper questions about why we are here and what existence really means. And often, when scientists run into problems or contradictions in their theories, it doesn't mean they've failed. On the contrary, it means they've discovered something worth investigating further. These scientific roadblocks are like signs pointing toward new discoveries. In fact, every time we struggle to understand something really complex, we learn something new. These struggles often lead to fresh conversations, better tools, and creative ways of thinking. Sometimes what looks like failure turns out to be the very thing that moves science forward. And by accepting that we don't know everything, we actually get a richer and deeper view of the universe. A view that celebrates both the limits and the great potential of human knowledge. As we explore these mysterious questions, we often find ourselves stepping into the world of philosophy. Philosophy is a field that tries to understand big, abstract ideas like truth, existence, morality, and consciousness. It may seem very different from science, which is based on tests, measurements, and experiments. But surprisingly, the two fields often overlap in interesting ways. For instance, take the question of consciousness. Philosophers have debated for thousands of years about what it means to be aware or to have a mind. Today, scientists are joining that discussion by studying how the brain works. With the help of advanced tools like functional magnetic resonance imaging, also called fMRI, researchers can see which parts of the brain light up when we think, feel, or make decisions. This helps us understand the connection between the brain and the mind, bringing a scientific lens to an old philosophical debate. In the same way, scientists have also started exploring morality. They run experiments in psychology and neuroscience to see how people make choices about right and wrong. These studies look at how things like peer pressure, personal beliefs, or cultural background influence moral decisions. Researchers collect data from people of different ages, places, and experiences, helping to make ethical questions more measurable and concrete. Another way science helps to explore philosophical ideas is by using a method called operationalization. This means taking an abstract concept, like happiness or justice, and finding a way to measure it. For example, scientists have created surveys and happiness scales to find out how people in different parts of the world feel about their lives. This lets researchers compare well-being across cultures and situations, giving shape to something that might otherwise seem vague or purely emotional. Thanks to these approaches, science and philosophy can work together like partners. Philosophers raise questions and offer ideas, while scientists test those ideas with real-world data and observations. It becomes a kind of ongoing conversation where both sides help the other grow. Questions about human nature, reality, and the meaning of life gain new depth when we look at them through both philosophical thinking and scientific research. These deep, thoughtful questions also show up in areas like cosmology, the study of the universe as a whole. Here, the line between science and philosophy gets especially blurry. One of the most powerful scientific ideas is the Big Bang theory, which describes how the universe began about 13.8 billion years ago. But while science explains how it might have happened, philosophy asks why it happened at all. Why does anything exist instead of nothing? That's a question science alone can't fully answer. Another fascinating issue is the nature of time. In physics, time is often seen as a kind of dimension, like space. But philosophers ask whether time is even real. Is it something that exists independently of our minds? Or is it just a way we organize our experiences? These questions challenge the way scientists talk about things like the age of the universe, or what might happen in the future. Even the way scientists observe the universe can raise philosophical questions. For example, the cosmological principle says that what we see from Earth should be similar to what's happening everywhere else in the universe. But how can we be sure? After all, we're stuck on this tiny planet, looking out from just one spot. Maybe our perspective is limited in ways we can't even imagine. However, the idea of the multiverse, multiple universes beyond our own, is not just a scientific theory. It also shakes up many of our philosophical beliefs. If there are countless other universes out there, each with its own version of reality, then what does that say about our own existence? Are we just one of many possible versions of reality? What does that mean for our understanding of truth, meaning, and purpose? As scientists explore the universe and make new discoveries, they are often guided by facts, measurements, and experiments. But standing beside them are philosophers who ask deeper, more difficult questions that science alone can't always answer. Scientists might explain how the universe works, how stars are born, how time behaves, or how galaxies move. But philosophers ask what these discoveries mean for us as human beings. What do they say about our place in the universe? What should we do with this knowledge? In this way, science and philosophy work together, each helping the other see the bigger picture. One of the most powerful and puzzling ideas today is the possibility of creating or changing a universe. This idea, which once belonged to science fiction, is now being seriously discussed by scientists and thinkers alike. But with this idea comes a wave of new questions, not just about what we can do, but what we should do. If humans ever reach the point where we can build a universe, or shape it in some way using advanced technology, or theories from physics, then we must ask, what is our moral duty? Should we interfere with nature? Should we worry about what kind of life might appear in that new universe? And who gets to decide what is right or wrong in a world we ourselves have created? These questions bring us into the world of ethics, the study of right and wrong. If one day we create artificial worlds, or even living beings that grow inside those worlds, we will need to think very carefully about how we treat them. Would those beings have rights? would we have a responsibility to protect them, just like we try to protect life on Earth? Even if the creatures we make are not like us, if they don't feel pain or speak our languages, do we still owe them something simply because we made them? These are not easy questions, but they are important ones. Our growing knowledge of the universe also makes us reflect on who we are. If we can build new worlds from scratch, does that change what it means to be human? Are we just curious creatures exploring the stars, or are we becoming creators ourselves? If we make a new kind of reality, can we still say we belong only to this one? In asking these questions, we also begin to think about our own origins, our identity, and what truly matters in a world where anything might become possible. These deep reflections show why it's more important than ever to connect science with philosophy. As our technology becomes more powerful and our ideas more daring, we must be sure our sense of right and wrong grows along with them. Talking about universe making isn't just about physics and numbers. It's also about values, choices, and responsibilities. Each new discovery opens not just a door to knowledge, but also a window into our soul. This close relationship between science and philosophy has existed for thousands of years. Back in ancient Greece, more than 2,300 years ago, great thinkers like Plato and Aristotle asked questions about life, reality, and the stars. They didn't separate science and philosophy. They saw both as parts of the same great search for truth. Plato's famous story of the cave, which tells of people seeing only shadows and mistaking them for reality, reminds us how easily we can misunderstand the world around us. That idea still inspires scientists today as they try to uncover hidden truths about the cosmos. Fast forward to the Renaissance around 600 years ago, and we find a huge leap forward in both science and philosophy. Thinkers like Francis Bacon said we should stop relying only on tradition and start learning by observing the world directly. This idea laid the foundation for modern science and encouraged people to question long-held beliefs about nature and the heavens. It was during this time that bold scientists like Nicholas Copernicus and Galileo Galilei challenged the old idea that the Earth was the centre of the universe. Their new theory, that the Earth and planets move around the Sun, forever changed how humanity saw its place in the cosmos. In the Age of Enlightenment about 300 years ago, brilliant minds like Isaac Newton showed how science could explain the universe using clear laws and mathematics. Newton's discoveries about motion and gravity helped people believe that the universe wasn't just chaos, but something that could be understood through reason. Meanwhile, philosophers kept asking tough questions about free will, about destiny, about how we know anything at all. Their ideas helped science grow deeper, and science, in turn, gave philosophy new ground to explore. Today, this partnership is still alive. In fields like quantum physics, we're learning that even something as simple as observation can affect the results of an experiment. New discoveries in science and technology are constantly changing the way we understand the origins of the universe. Things that were once only talked about in theory or imagination are now becoming possible thanks to amazing breakthroughs. One of the most exciting advancements is in a field called gravitational wave astronomy. This science allows us to detect tiny ripples in the very fabric of space and time, ripples that are created when massive objects like black holes or neutron stars crash into each other. These cosmic vibrations help us peek into the earliest moments of the universe, revealing mysteries that ordinary telescopes simply cannot see. With this powerful tool, scientists can now study the most extreme and violent events in space, like the smashing together of collapsed stars or the swirling dance of black holes, giving us a much fuller and more detailed story of how the universe evolved over time. At the same time, artificial intelligence is becoming a game changer in space science. AI can analyze huge amounts of data gathered from telescopes, satellites, and computer simulations, far more than a human could handle on their own. It can spot patterns, strange signals, and hidden clues that might otherwise go unnoticed. Thanks to machine learning, a type of AI that gets smarter over time, we're getting better at understanding the cosmic microwave background, the faint glow left over from the Big Bang, as well as spotting incredibly faraway galaxies that existed in the universe's early years. This helps scientists sharpen their theories about how the universe formed and how it grew into what we see today. Meanwhile, the creation of powerful new space telescopes is opening up even more doors. One of the most important of these is the James Webb Space Telescope, which was launched in the year 2021. Unlike regular telescopes that see visible light, the James Webb can look at infrared light, which lets it see through thick clouds of space dust. This means it can observe the birth of stars and galaxies in ways never before possible. It can show us, in incredible detail, how the first galaxies came to life and how the universe changed over billions of years. But the search for cosmic truth doesn't stop there. Scientists working in particle physics are also making amazing progress. Facilities like the Large Hadron Collider, a huge underground machine in Europe, are helping researchers study the tiniest building blocks of the universe. This includes the fundamental particles and forces that shaped the universe just after the Big Bang, which happened around 13.8 billion years ago. Some scientists even believe these particles might reveal clues about what happened before the Big Bang. It's possible, they say, that the Big Bang wasn't the beginning of everything, but just a turning point in a much larger cosmic story. Theoretical models like string theory and loop quantum gravity suggest that the universe may have existed in a different form before the Big Bang, and then changed into what we know now. By smashing particles together at very high energies, similar to the conditions just after the Big Bang, scientists can test these bold ideas. Another part of this search focuses on the mysterious substances known as dark matter and dark energy. These invisible components make up most of the universe, yet we still don't fully understand what they are. If we can find out how dark matter interacts with regular matter, it might reveal hidden structures in the universe that go back even farther than the Big Bang. High-energy space events like gamma-ray bursts and the afterglow of the Big Bang, called the cosmic microwave background, also provide important clues. They help us understand how energy and matter behaved in those early chaotic times. Some researchers believe that certain cosmic patterns in this radiation may hint at what set the stage for the Big Bang itself. However, studying the universe's childhood is far from easy. One of the biggest challenges is time itself. The universe is roughly 13.8 billion years old, and to study its beginning, scientists have to look back to a time less than a trillionth of a second after the Big Bang. Back then, temperatures were unimaginably high, and everything was packed tightly together in a way we can barely recreate or study in any lab on Earth. During this early era, known as the epoch of the cosmic microwave background, the universe was filled with intense energy and radiation. Observing traces of this ancient light requires incredibly sensitive tools that can filter out all the noise created by our own galaxy and other cosmic sources. Even space-based telescopes must overcome interference and confusion to catch a clear glimpse of this primordial glow. Another problem is that our current scientific theories sometimes don't work well together. For example, general relativity explains gravity and the large-scale structure of space, while quantum mechanics deals with the tiniest particles. But when you try to use both at the same time, especially to describe the universe's earliest moments, they often clash. That's why scientists are working hard to develop new models that can combine these ideas into a single, unified theory. Studying how the very first stars and galaxies formed also presents tough puzzles. These ancient structures are so far away, and their light so faint, that only the most advanced telescopes can detect them. Even then, what we see may not always match what our theories predict, forcing scientists to go back, ask new questions, and improve their understanding. When we look deep into the universe, we're not seeing things as they are right now. We're looking far back in time. The light from distant galaxies takes billions of years to reach us, which means we are actually observing how those galaxies looked billions of years ago, not how they look today. So, our view of the cosmos is like a time-travelling photograph, but one that's been altered by countless ages of cosmic change. What we see is only a glimpse, shaped and sometimes distorted by the long journey that light has taken through space and time. Each new discovery we make about the universe opens up more questions than answers. Instead of solving mysteries, we often find new ones, and this keeps pushing the limits of what we know. It also reminds us just how complex, mysterious, and awe-inspiring the universe truly is. In recent years, especially in the field of astrophysics, scientists have uncovered ideas that challenge some of the oldest beliefs about how everything began, even before what we call the Big Bang. For a very long time, many scientists believed that the universe began from a single point, known as a singularity. This point was said to have infinite density and temperature. In simpler terms, everything in the universe was squeezed into one tiny spot, and time itself began with this enormous explosion of creation. This idea raised a big and puzzling question. If time started with the Big Bang, then what came before it? Could anything even exist before time? Thanks to powerful new instruments and observational tools, scientists are now able to explore deeper into the universe than ever before. These tools have revealed things that suggest the early universe was far more complicated than we used to think. For example, in the late 20th century, that is the late 1900s, astronomers discovered that the universe isn't just expanding, but that it's expanding faster and faster. This unexpected acceleration led to the discovery of something called dark energy, a mysterious and invisible force that seems to be stretching the universe apart. Dark energy has changed how scientists think about the history and future of the cosmos. It raises strange and exciting ideas about what the universe was like before the Big Bang. Some theories suggest that there wasn't just one beginning. Instead, the universe might have gone through many cycles, expanding, then shrinking, then expanding again, like a great cosmic heartbeat. This idea is known as the cyclic universe model. Another fascinating area of study is the cosmic microwave background radiation. This is the faint glow of heat left over from the early universe, like the dying embers of a once roaring fire. By studying tiny changes, called fluctuations, in this radiation, scientists can learn what the universe might have looked like just moments after the Big Bang. These patterns may even offer clues about events or structures that existed before the Big Bang, opening up entirely new ways to think about time and existence. Some scientists have even gone a step further. They wonder if our universe is just one among many, a part of something called the multiverse. In this idea, each universe could have its own laws of physics, its own beginning, and its own story. If this is true, then the universe we live in might be just one chapter in a much larger book of creation. With each new discovery, scientists find themselves standing at a crossroads, where old ideas meet new evidence. The story of the universe keeps changing as we learn more, becoming richer, deeper, and more full of wonder. Every question we answer brings two more in its place, especially when it comes to things like dark energy. Dark energy is believed to make up about 70% of everything in the universe, and yet we still don't know exactly what it is. It seems to be the reason why galaxies are moving away from each other faster and faster, instead of slowing down as we once expected. Right after the Big Bang, the universe began to expand rapidly. Then, as it cooled and matter started forming stars and galaxies, many scientists thought that gravity would gradually slow this expansion. But that's not what happened. Around 5 billion years ago, something changed. The expansion of the universe began to speed up instead of slow down. That's when dark energy took over. As the universe grew older, dark energy became more powerful, overpowering gravity and sending galaxies flying apart at increasing speeds. This means the universe is not only growing larger, but also doing so faster and faster. It's like blowing up a balloon that expands more quickly the bigger it gets. This strange behavior raises big questions about the future of everything. Will galaxies continue drifting so far apart that the universe becomes cold and empty? Or could dark energy change somehow, allowing gravity to pull things back together again? No one knows for sure. But what we do know is that dark energy has completely changed how we think about the past, the present, and the future of the cosmos. Dark energy doesn't just affect physical things, it affects our thinking too. It forces scientists to revisit some of the deepest theories in physics and to question what we thought we understood. It leaves us with the exciting possibility that the universe still has secrets waiting to be discovered. In recent years, a new way of exploring the universe has emerged, not just through science, but also through art. When science and art come together, something powerful happens. Art has a unique ability to stir our emotions and help us imagine things that are hard to put into words. Scientific ideas can often feel distant and abstract, but when artists create paintings, music, or films about space and time, they help make those ideas come alive. A picture of a star being born or a swirling galaxy can speak to the heart in a way that numbers and graphs often can't. At the same time, science adds structure and truth to artistic expression. When artists use real data and research, their creations become more than just fantasy. They become reflections of the universe as it really is. This collaboration can produce amazing experiences, like immersive exhibits that let people feel what it might be like to drift through space or witness the birth of a star. These projects do more than just entertain. They can awaken curiosity, especially in young people. When children see the beauty of the universe captured through art, they may be inspired to ask questions, dream big, and one day become scientists or artists themselves. This blend of imagination and investigation helps make science more accessible to everyone, inviting people from all walks of life to join the journey of discovery. In the end, bringing science and art together helps us tell a fuller, more human story about the cosmos. It helps us not only understand where we came from, but also feel our connection to the stars. The universe isn't just made of galaxies and particles, it's also made of questions, dreams, and the endless wonder that unites us all. Even the way we see the universe is affected by this mix of science and creativity. Scientists often use visual tools, like computer models, animations, and illustrations, to help explain things that are too vast or too tiny to imagine. A black hole, for example, can't be seen with the naked eye, but thanks to visualizations, we can understand what it might look like and how it behaves. These images help turn complicated theories into something we can almost touch and feel. When we watch a simulation of a cosmic event, like the birth of a star, the collision of galaxies, or the swirling dance of black holes, we're not just seeing something pretty on a screen. We're taking part in a bridge being built between science and everyday people. These visual experiences help bring the mysterious, faraway universe closer to our minds and hearts, creating a connection that inspires curiosity and wonder. One of the biggest strengths of these visualizations is their power to show us just how huge and strange the universe really is. It's hard for anyone to imagine what a million light-years really means, or how powerful the forces are that shape a galaxy. But with a computer-generated video or interactive image, those enormous numbers and abstract ideas become something we can actually see and understand. Instead of just hearing that a galaxy is millions of light-years away, we can watch it form in slow motion, see it swirl and stretch, and start to grasp the grandness of it all. These visual tools take us on a journey from the fiery explosion known as the Big Bang, which happened around 13.8 billion years ago, to the peaceful orbits of stars and planets dancing across the sky today. They show us more than words and numbers ever could. For example, when we see two supermassive black holes crashing into each other, the event feels real and awe-inspiring. We can even see the invisible ripples that move through space-time, called gravitational waves, spreading out like waves in a pond. Watching such a dramatic moment unfold helps us feel the scale, the energy, and the beauty of the universe. Even more exciting are the interactive visualizations, digital tools that let you change things and see what happens. You can adjust the size of a star, shift the gravity, or speed up time, and then watch how the whole system changes. This makes learning about space more like playing a game, where experimenting with ideas leads to deeper understanding. Instead of being passive viewers, we become active explorers in the story of the universe. But science is not the only way we try to understand where we come from. Art also plays a powerful role in helping us make sense of the cosmos. Artistic interpretations of the universe's beginnings take scientific ideas and turn them into emotional experiences. Artists use bright colours, swirling shapes, and rich textures to show the wonder and mystery of creation. In a painting, the Big Bang might look like a glowing burst of colour exploding outward, with galaxies spinning out like fireworks. This kind of art stirs our feelings and helps us imagine what the birth of the universe might have felt like. Science, on the other hand, is more focused on precision. Scientific representations rely on careful measurements, equations, and data collected by telescopes and satellites. Instead of swirls of colour, you might see a chart showing how the universe expanded over time, or a diagram of tiny particles forming in the first moments after the Big Bang. These scientific images explain how things happened, but they don't always touch the heart the way art can. Still, both science and art are trying to answer the same big questions. Where did we come from? What is the universe made of? How did it all begin? Science gives us facts and explanations. Art gives us feeling and imagination. Together they offer a fuller picture of reality. While science keeps us grounded in what we can prove, art lets us dream and wonder about what we may never fully understand. The two approaches balance each other, and together they help us explore not just the universe, but our place in it. Today, another powerful tool is helping us explore the cosmos in entirely new ways: artificial intelligence, often called AI. This advanced technology is becoming an essential partner in astronomy and cosmology. AI can process gigantic amounts of information gathered by telescopes, space probes, and satellites, more data than any human could possibly sort through. It looks for patterns and unusual signals, picking out details that might be too small or complex for scientists to notice on their own. One of the most impressive things AI can do is study the cosmic microwave background radiation. This is a faint, ancient glow left over from the very early universe, just a few 100,000 years after the Big Bang. Tiny changes in this radiation contain secrets about how the universe was born and how it has evolved over the last 13.8 billion years. AI is helping scientists spot these tiny clues and build better theories about the beginning of time, the nature of dark matter and dark energy, and much more. AI is also helping in other exciting areas. It can help classify galaxies, spot new planets around distant stars, and even predict when a star might explode in a supernova. These predictions are made by teaching AI to recognize certain patterns in data, similar to how our brains notice patterns in music or faces, but on a much bigger and faster scale. But AI is not just analyzing data. It's also helping scientists build new simulations of how the universe might work under different conditions. Scientists can run these simulations to test different theories about gravity, expansion, or how galaxies form. AI helps sort through the results and pick out which ideas match reality the best. As AI keeps improving, its role in space science will only grow. It opens up exciting new possibilities for discovery. By finding connections no one expected and helping design smarter experiments, AI is changing the way we do science. It's pushing the limits of what we know and inviting us to see the universe in entirely new ways. Theories about how the universe began aren't just distant scientific ideas, they actually help shape how we see the world around us, and even how we think about our own lives. At the center of these ideas is the Big Bang theory. This theory suggests that the entire universe started around 13.8 billion years ago, from a tiny, unimaginably hot and dense point. Then, in a single incredible moment, everything we know, space, time, energy, and matter, suddenly expanded outward. That moment laid the foundation for the stars, galaxies, and planets we see today, including Earth, our home. As scientists have studied how the universe has changed and grown since that beginning, they've uncovered something truly amazing. Every single atom in our bodies was once part of a star. That means the iron in our blood, the calcium in our bones, and the oxygen we breathe all came from the fiery hearts of ancient stars that exploded long ago. This discovery creates a powerful connection between us and the universe. We are not just living in the cosmos, we are the cosmos. We are made of stardust. Realizing this changes how we see ourselves. Our elements, like carbon, nitrogen, and oxygen, were created in stellar furnaces and scattered across space, eventually coming together to form life on Earth. Each breath we take and every beat of our heart carries the story of ancient stars. These theories do more than just explain how the universe began. They also spark deep questions about who we are and why we're here. If time, space, and matter all had a beginning, what does that mean for our own beginnings and ends? It pushes us to think harder about big ideas like cause and effect, the meaning of time, and what might come next, not just for stars and galaxies, but for people and entire civilizations. Thinking about the origin of the universe lifts us out of our daily routines and challenges us to reflect on our place in a much larger story. This search for understanding lights a fire in our minds, It drives curiosity and creativity. It influences scientists, philosophers, writers, and even artists. Looking up at the stars or imagining the Big Bang can open our eyes to the wonders of existence. It can make us feel connected to the universe and to each other. Every time we wonder about where everything came from, we also begin to uncover the deeper layers of what it means to be alive. And these ideas are not just abstract science, they touch us personally. When someone starts to think seriously about how the universe, life, or even consciousness began, it often makes them reflect on their own identity. Where do we come from? What is our purpose? These questions can lead to deep, life-changing realizations. Some people may find that their beliefs are challenged by scientific discoveries like the Big Bang or evolution. Others may find their faith or sense of meaning become stronger. Either way, these reflections shape how people see themselves and the world around them. Different people interpret the origins of the universe in different ways. Some view it through science, others through religion, spirituality, or philosophy. These varying perspectives add richness to the conversation. They allow us to build a more thoughtful, layered understanding of existence. When people from different cultures or belief systems discuss these big questions together, they often grow, not just in knowledge, but in empathy, understanding, and self-awareness. In this way, studying where everything came from acts like a mirror. As we try to understand the universe's beginning, we're also learning more about ourselves and each other. This connection between cosmic knowledge and personal meaning turns ordinary conversations into powerful reflections about life, identity, and the human experience. Public interest in cosmology, the science of the universe, can deeply influence how people respond to big global challenges. When someone learns that Earth is just a small planet in an endless universe, it often inspires a sense of humility. It can also awaken a strong feeling of unity. After all, we all live on the same tiny world, sharing the same stardust origin. This shared identity can encourage people to care more deeply about protecting the planet, solving problems like climate change, and treating each other with respect and compassion. Understanding the universe in this way can replace feelings of fear or loneliness with a sense of belonging. Instead of seeing crises as the end of the world, we can view them as part of a much longer story, and something we have the power to change together. Curiosity about the universe can also be healing. When people feel lost or uncertain, learning about black holes, star life cycles, or the size of the cosmos can offer comfort. It turns fear into fascination. It helps people see that not knowing everything isn't something to dread. It's an invitation to explore, to imagine, and to keep learning. This new way of thinking can turn personal or global crises into moments of discovery and growth. Media, documentaries, books, podcasts, and public talks about the universe also play a big role. They spark conversations, challenge our thinking, and help us form deeper ideas about existence. These discussions help communities become more thoughtful, resilient, and united. They give people tools to think more clearly and creatively about the future. As more people engage with the story of the universe, they discover not just facts, but wisdom. They begin to see life's challenges in a new light and develop a hopeful outlook. The story of the universe becomes a shared story. Finally, learning about the universe's history helps us see the full, breathtaking journey that brought us to this moment. From the Big Bang almost 14 billion years ago to the formation of stars, galaxies, and Earth itself, the universe tells a story of wonder and change, and we are part of it. When we understand that our atoms were made in the hearts of stars, we begin to see that we are not strangers in the universe, we are its children. This deep connection with the cosmos can inspire unity, compassion, and purpose. It encourages us to care for one another and for the planet we all share. Our differences become less important when we remember how much we have in common. We're all travelers in the same cosmic story, reaching for understanding, meaning, and light. Learning about the history of the universe does much more than just satisfy curiosity. It helps us think far beyond our everyday lives. It pushes us to ask big, important questions about the future of humankind. What kind of world are we leaving behind for future generations? How can we work together to solve the problems facing the planet today? When we look at the story of the cosmos, it opens our minds to bigger possibilities. It encourages teamwork and sparks new ideas. This way of thinking reminds us that we are all connected, not just to each other, but to the entire universe. It can inspire people to care more deeply for the Earth and everything beyond it. With this cosmic point of view, we begin to imagine a future built on hope, curiosity, and a shared sense of purpose. Embracing our place in the universe helps us feel like more than just people living on a single planet. It helps us see ourselves as explorers and caretakers of a fragile world spinning in a vast ocean of stars. As we reflect on where we came from and wonder where we're going, we're united by something bigger than borders or differences. We're all travelers, journeying together into the unknown. Understanding how the universe began gives us a powerful way to connect with something far larger than ourselves. Scientists believe that the universe started with a massive event called the Big Bang, which happened around 14 billion years ago. This idea helps us see our existence as part of a huge cosmic story that stretches back to the very beginning of time. Just thinking about this can fill us with awe. It makes us wonder about life, the meaning of existence, and our special place in the grand design of the cosmos. It also expands our imagination and invites us to marvel at the beauty of everything, from swirling galaxies to the invisible forces that shape the stars. When we realize that every atom in our bodies was once created inside ancient stars, we begin to understand how deeply we are connected to the universe. We are, quite literally, made of stardust. This knowledge can make us feel a sense of unity with the world, with each other, and with the cosmos itself. But at the same time, learning about how vast and ancient the universe is can be overwhelming. It can make our own lives feel small in comparison. The endless size of space and the billions of years behind us can lead some people to question their purpose or feel lost in the face of such a huge mystery. It's a reminder that we are tiny in the grand scale of things and that our time here is short. Still, this feeling of being small doesn't have to be a bad thing. In fact, it can help us better understand how precious life is. It can inspire us to build strong relationships, care more for the world around us, and find meaning in the moments we share. Instead of feeling less important, we might feel more connected to each other and to the universe. Learning about our cosmic past is like slowly putting together a giant puzzle. Each piece we find helps us understand how everything, from stars to planets to life itself, came to be. For example, by studying the faint light left over from the early universe, known as the cosmic microwave background, scientists can look back almost to the very beginning of time. This helps us figure out how galaxies formed and how the universe has changed over billions of years. This deep understanding of the past also helps guide the future. It gives scientists clues about where to search for alien life, both in our solar system and far beyond. When we understand what makes life possible here on Earth, like water, the right chemicals, and a steady energy source, we can look for those same signs on distant worlds. This is why missions are being planned to explore places like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, where hidden oceans may hold the ingredients for life. Studying space also helps us prepare for cosmic dangers. Events like exploding stars, called supernovae, and powerful energy bursts, known as gamma-ray bursts, can affect life on Earth. By learning more about these events, we can better protect ourselves in the future. As science continues to move forward, technology does too. New telescopes, robotic spacecraft, and advanced tools are making it easier to explore the universe. Each discovery builds on the last, helping us go further and understand more. This never-ending quest for knowledge fuels inventions that could change how we live and travel in space. Of course, not everyone believes these theories right away. Throughout history, many people have questioned scientific ideas. This kind of public doubt or skepticism is actually very useful. When people challenge scientists, it forces them to test their ideas more carefully and make their theories stronger. For example, the Big Bang and the idea of cosmic inflation were once seen as strange or uncertain. But over time, with more evidence from telescopes and space missions, these theories gained widespread support. Public questions and debates also help improve science education. When people are confused or doubtful, scientists and teachers have a chance to explain things more clearly. This helps more people understand how science works. not as a list of facts, but as a process of discovery that keeps growing and changing as we learn more. It's fascinating how doubt and curiosity often go hand in hand, especially when it comes to big questions about the universe. When people feel unsure about certain scientific ideas, like how the universe began or what it's made of, that doubt can actually spark a deeper interest. Instead of blindly accepting facts, many start asking questions and looking for answers themselves. They begin to explore how stars form, what galaxies are made of, or how the Big Bang might have happened. This kind of curiosity leads people to learn more about science, making society smarter and better, prepared to deal with important scientific topics. Even though skepticism, or the act of questioning what we're told, can sometimes slow down the acceptance of new ideas, it also plays a positive role. By challenging popular beliefs, public doubt forces scientists and educators to explain their ideas more clearly. It pushes scientific theories to become stronger and better understood. In this way, skepticism can be seen not as a roadblock, but as a powerful tool that helps people really understand the universe, not just believe in it. When we talk about how everything began, we're actually looking back more than 13 billion years to a moment known as the Big Bang. This wasn't just an explosion in space, it was the birth of space and time itself. From that single point came all the stars, galaxies, planets, and eventually life. Thinking about such an enormous timescale changes the way we see ourselves and our world. It helps us realize that Earth is not just a random planet. It's a very rare and precious place in the middle of a vast, dark universe. As scientists continue to uncover the story of the cosmos, from the creation of stars to the formation of planets and the rise of life, they also help us understand just how special Earth really is. Our planet was formed under extremely specific conditions. If even a few things had gone differently, Earth might never have been able to support life at all. This realization makes us feel more responsible for protecting it. We begin to see that nature isn't something separate from us. We are part of it, and we must take care of it. In this big picture view, Earth becomes more than just our home. It becomes a tiny green and blue island floating in a huge and mostly empty universe. And because it's the only place we know that supports life, we start to understand how fragile it is. This awareness leads to a deeper respect for our environment, and it reminds us that the natural systems keeping us alive, like the air we breathe and the water we drink, are not endless. They can be damaged, and once broken, they might not be easily fixed. As we learn more about how the universe works, we also gain new ideas about sustainability, how to live in ways that protect our planet for future generations. Just like stars are born, shine brightly for millions or even billions of years, and then fade away, our own way of life must also change over time. We can't keep using up resources without thinking about the future. By studying the stars and the natural laws that shape the universe, we find inspiration to use clean energy, protect wildlife, and reduce pollution. The stars are not just beautiful to look at, they are teachers too, showing us how everything in nature goes through cycles of change. Looking at the universe on such a huge time scale also helps us think differently about the problems we face today, like climate change and the loss of animal species. These are serious challenges, but when we view them in the context of billions of years of cosmic history, we can take a step back and see the bigger picture. We learn that while life on Earth is delicate, it is also incredibly strong and adaptable. This knowledge gives us hope. It encourages us to make smart choices and come up with new solutions so we can keep living and thriving here. Knowing that we come from the stars and that every atom in our bodies was once part of a star makes us more likely to protect our planet. It fills us with a sense of wonder and responsibility. We don't just want to survive, we want to make sure Earth continues to be a place where life can flourish. But science isn't the only way we connect to the universe. Art has always been a powerful way to explore big ideas about space, time, and our place in the cosmos. Humans have been looking up at the stars in wonder for thousands of years, and they've often expressed that wonder through painting, sculptures, music, and writing. Artists take the mystery and beauty of the universe and turn it into something we can feel with our hearts. During the Renaissance, a time of great discovery that began in the 14th century and lasted into the 17th century, artists started adding scientific ideas to their work. Some were even influenced by the discoveries of scientists like Galileo Galilei, who lived in the late 1500s and early 1600s. Artists studied light and shadow to better understand space and time. Others, like Vincent van Gogh in the late 1800s, used swirling lines and bright colours to paint emotional, dreamlike versions of the night sky. His famous work, Starry Night, is not just a painting of stars, it's a way of expressing the wild, beautiful energy of the cosmos. In modern times, artists have new tools to work with, like digital technology and immersive installations. Artists such as Olafur Eliasson use light, mirrors, and space to create environments that make viewers feel like they are standing inside the universe. These works of art don't just show us the stars, they make us feel like part of them. People don't just look at the art, they interact with it, think about their place in the universe, and even question the meaning of time and existence. Writers and poets, too, have long explored cosmic themes. Books by thinkers like Carl Sagan or stories by Jorge Luis Borges dive deep into questions about the meaning of life in such a huge, mysterious universe. Through stories and poems, writers help us think about things that science sometimes struggles to explain, like love, death, beauty, or purpose. The deep desire to understand where we come from, even before the universe as we know it began, is one of the most powerful forces driving both scientists and philosophers. For centuries, people have looked up at the stars and wondered, what came before everything? What existed before the Big Bang? The Big Bang Theory tells us that the universe started about 13.8 billion years ago from an unimaginably hot and dense state. But this theory, as fascinating as it is, doesn't explain what, if anything, came before that explosive moment. That mystery keeps pushing scientists to explore new ideas, to look past what is already known, and to enter into the mysterious worlds of theoretical physics and deep philosophical thinking. At the heart of this exploration is a simple but profound question: where did everything come from? Scientists are eager to find answers. They want to uncover the basic rules that govern the universe, what makes it tick. They study clues hidden in the faint glow left over from the Big Bang, known as the cosmic microwave background, in how galaxies behave, and in the strange rules of quantum physics, which describe the tiniest parts of nature. Some scientists even wonder if our universe is just one bubble among many in a vast multiverse. Others ask if time itself might have behaved differently before the Big Bang, if there even was a before. One idea, called inflationary theory, says that right after the Big Bang the universe expanded incredibly fast. But this idea also leads to more questions. What caused this sudden growth? What came before it? While scientists dig into the physics, philosophers think deeply about the meaning behind these questions. They ask, what does it really mean for something to come from nothing? Can we even imagine such a thing? Their discussions touch on huge ideas like infinity, time, cause and effect, and the very nature of reality. These are things that science alone might not be able to fully answer. Philosophy helps put our search for truth into a larger human context. Together, science and philosophy make a powerful team. Their shared journey leads to rich conversations and new ways of thinking. These ideas can help us reshape how we understand not only the universe but also ourselves, our existence, our place in the cosmos, and our responsibilities as thinking, feeling beings. The story of how we've searched for answers about the universe's beginnings goes back thousands of years. Long ago, ancient cultures made up stories to explain what they saw in the sky. The Babylonians and the ancient Greeks looked at the stars and planets and created myths, imagining gods moving the heavens. These early myths, although not scientific, showed a deep curiosity and a desire to make sense of the world. As time passed, human thinking evolved. During the Renaissance, a period of renewed interest in learning and discovery that began in the 15th century, great thinkers started to question old beliefs. One of them, Nicholas Copernicus, suggested something bold: that the sun, not the Earth, was at the centre of our solar system. This idea was shocking at the time and sparked many debates, but it opened the door to a new way of understanding the cosmos. Later, in the 17th century, scientists like Johannes Kepler and Galileo Galilei changed our view even more. Kepler showed how planets move in elliptical orbits, not perfect circles. Galileo used a telescope to observe the moon, the planets, and the stars in ways never done before. These discoveries made it clear that learning about the universe required careful observation and evidence, not just stories or guesses. In the 19th and 20th centuries, our understanding took another giant leap forward. The idea of the Big Bang was born. In the year 1929, astronomer Edwin Hubble noticed that distant galaxies were moving away from us, suggesting that the universe is expanding. This meant the universe had a beginning, and that it was still changing. As technology improved, we built more powerful telescopes and tools, allowing us to look farther into space and deeper into the past. Today, in the 21st century, our quest continues with even more advanced methods. Scientists now use tools like gravitational wave detectors and sensitive instruments that study the afterglow of the Big Bang to learn about the very early moments of the universe. With each new discovery, we get a little closer to understanding the forces and materials that shaped everything we know. But our journey isn't just scientific, it's also ethical and deeply human. As we dig into questions about where we came from and what reality truly is, we also have to ask, what should we do with this knowledge? How might these discoveries affect people's beliefs or the way society works? For example, what if a new theory about the universe's beginning goes against someone's religious view? How do we talk about these things in a respectful and thoughtful way? And as we study the brain and consciousness, we face new questions. Is it right to use technology to explore or even change how people think? Where do we draw the line between helping and interfering? There's also the question of cost. Research into the universe takes time, money, and human effort. So we must ask, how do we balance this search for knowledge with other urgent needs, like fighting poverty, protecting the environment, or improving healthcare? And there's the responsibility of scientists and communicators. It's important that discoveries are shared honestly and clearly. If scientific ideas are misunderstood or twisted, they can lead to confusion or fear. That's why ethics must always walk alongside science. Understanding science is incredibly important when it comes to how people think about big questions, like where the universe came from, what black holes really are, and whether life exists on other planets. When people learn the basics of how science works, how scientists test ideas, study evidence, and build on what they already know, they are much better prepared to understand these complicated topics. Instead of seeing space science as something mysterious or confusing, they can begin to see the bigger picture and join in thoughtful discussions about the universe and what it means for our lives here on Earth. This kind of scientific understanding, often called scientific literacy, also helps people think more clearly and carefully. It teaches them how to check facts, look at where their information comes from, and question wild or unbelievable claims. This kind of thinking is especially important today, in a world where false information spreads so easily through the internet and social media. For example, knowing how the scientific method works helps people appreciate just how carefully scientists have to work to make major discoveries, like the detection of the cosmic microwave background radiation, a very faint signal left over from the universe's earliest moments, which gives us clues about how everything began. When more people understand science, support for scientific research often grows. People are more likely to agree that funding should go toward projects like space missions or new kinds of powerful telescopes. These tools help us look deeper into the sky and uncover more about the cosmos. A community that values science will also push for better science education and support research centres that explore outer space and the mysteries beyond our planet. As people from all kinds of backgrounds get involved in these conversations, the story we tell about the universe becomes even richer. Everyone brings their own experiences, cultures, and ideas to the table, which helps us see things in new ways and ask better questions. In the end, a world where more people understand science is one where curiosity can thrive, especially about the deepest questions, like why we're here and what our place is in this vast universe. In the world of science, some ideas are easier to test than others. Normally, a scientific idea, called a hypothesis, is supposed to be tested by doing experiments or making observations. But some questions, especially in the field of cosmology, which studies the entire universe, are much harder to test because they involve things we can't see or reach with our current technology. For example, scientists still don't fully understand dark matter and dark energy, which seem to make up most of the universe. These strange forces behave in mysterious ways, and no one knows exactly what they are yet, making it difficult, if not impossible, for now to test ideas about them directly. To deal with this challenge, scientists use many different tools and methods. First, they create theories based on solid evidence and knowledge they already have. Then, they build models that help predict what might happen in different situations, even if those situations are impossible to recreate in a lab. These models help guide future research, and can even suggest what scientists should look for next. Sometimes, new inventions open the door to testing ideas that once seemed impossible. A good example is gravitational waves, tiny ripples in space-time that were predicted by Albert Einstein more than 100 years ago. For a long time, no one could detect them. But thanks to the development of extremely sensitive detectors, scientists were finally able to prove they exist in the year 2015. That discovery was a huge leap forward and showed how persistence and better tools can turn wild theories into proven facts. Even when scientists can't test an idea directly, they look at what else the idea might suggest. They might ask, if this theory is true, what else should we be able to see or measure? From there, they create smaller testable ideas that could support or challenge the original theory. This way, science stays careful and thoughtful, even while exploring unknown territory. By combining strict logic with imagination, scientists keep pushing forward, getting us closer to understanding the universe's biggest mysteries. Working together across different fields can also help us explore deep and meaningful questions that deal with why we exist, how everything began, and what it all means. When scientists, philosophers, theologians, and thinkers from all kinds of academic backgrounds join forces, they bring a mix of ideas that make the search for answers more complete. For example, by combining scientific methods with philosophical thinking or religious insight, we can look at complex questions, like the nature of consciousness or the meaning of life, from multiple angles. More and more, universities and research centres are encouraging this kind of teamwork. Conferences and workshops focused on big questions about existence are becoming more common. In these spaces, people share ideas freely, and new connections are often made. Connections that might not appear if everyone stayed in their own narrow field of study. Public involvement also makes a difference. When everyday people are invited into these conversations through public talks, community events, or educational programs, it brings fresh questions and personal stories that can spark new ideas. It also helps make science and philosophy feel more open and democratic, rather than something reserved only for experts. Modern technology helps this collaboration grow too. Thanks to the internet and video calls, researchers all over the world can work together, share findings, and build projects without needing to be in the same place. This global teamwork speeds up discovery and adds even more variety to the way we think about the biggest questions life has to offer. Looking at history can help us better understand how our ideas about the universe have changed over time. For thousands of years, humans have asked questions about where the stars came from, what lies beyond the sky, and why we're here. Ancient cultures often told stories that explain the universe through the actions of gods or spirits. These myths were early ways of trying to make sense of the unknown, and show that humanity's curiosity about the cosmos is nothing new. Later, thinkers like Claudius Ptolemy and Nicholas Copernicus started building new models of the universe, ones that used math and observation instead of myths. These scientists helped shift our view of the cosmos from a magical place ruled by gods to a system that could be studied and understood. Big leaps came with figures like Isaac Newton, who discovered the laws of motion and gravity in the 17th century, and Albert Einstein, who transformed our understanding of space and time in the early 20th century. These discoveries changed the way we think about everything from falling apples to black holes. Learning about these historical milestones helps us realize that science is a journey. Each new idea builds on the work of those who came before. It reminds us that understanding the universe isn't about having all the answers right away. It's about being part of a long, exciting search that spans centuries. When we think about how the universe began, especially during massive events like the Big Bang, we're not just looking at scientific theories. we're also drawing from a long history of human thought, filled with ideas from both science and philosophy. These past perspectives shape the questions we ask today and influence the way we try to answer them. They remind us that the search for the beginning of everything is not just a modern curiosity. It's a journey that has been unfolding for thousands of years, guided by both evidence and imagination. This deep and fascinating quest to understand our universe is one of the greatest adventures of the human mind. It brings together ideas from many different areas of knowledge, including physics, astronomy, cosmology, philosophy, and even psychology. Each of these fields offers its own way of looking at the universe. Scientists and thinkers work hard to build a full picture of how the cosmos works, but this is no easy task. One major challenge comes from the fact that these fields often speak very different languages. For example, physicists use math and experiments to test their ideas, while philosophers often rely on deep thinking, reasoning, and exploring abstract questions. Trying to connect these different ways of thinking requires open-mindedness and a true willingness to cooperate. But that's not always easy. Sometimes the differences in approach make it feel like trying to fit puzzle pieces together when they come from completely different puzzles. Each field also looks at the universe from a unique point of view. A physicist might study the tiniest building blocks of matter, like particles and forces at the quantum level, while a cosmologist focuses on the largest structures imaginable, such as galaxies, stars, and the faint glow left over from the beginning of time, known as cosmic background radiation. Both views are incredibly important, and both are full of complex questions. But blending these views into a single, unified understanding of the universe takes creativity, teamwork, and a willingness to explore new ideas. There's also another big challenge: the fact that science never stands still. New discoveries are constantly being made, and sometimes these discoveries shake the foundations of what we thought we knew. For example, the discovery of mysterious things like dark matter and dark energy, two strange forces that make up most of the universe but can't be seen, has forced scientists to rethink old models of how the universe works. Because of this, any complete picture of the universe must be flexible. It has to be able to change as new information comes to light. But changing long-held beliefs isn't always easy, especially in academic and philosophical communities that may prefer sticking to traditional ways of thinking. However, there's the problem of communication. Every field has its own technical terms and complex language, which can make it hard for experts in one area to talk clearly with those in another. This can slow down progress and make teamwork harder. That's why it's so important for scientists, philosophers, and other thinkers to explain their ideas in clear, simple language. Not just for each other, but for the public too. When we make knowledge easier to understand, more people can join the conversation and become part of the incredible journey to understand the cosmos. In the distant future, people will probably look back at our current ideas about how the universe began, like the Big Bang Theory and the idea of cosmic inflation, and see them in a completely new way. As time passes and science keeps moving forward, new discoveries and better technologies will likely give future scientists a deeper, richer understanding of the cosmos. What we now believe to be cutting-edge or groundbreaking might one day seem basic, or even a little naive. Right now, we rely heavily on what we can observe through telescopes and what we can calculate with mathematics. These tools have helped us create the theories we trust today. But as we learn more, these same ideas could be changed, updated, or even completely replaced. For example, our current understanding of dark matter and dark energy, two mysterious things that make up most of the universe, might shift dramatically once we figure out more about how the universe really works. It's possible that future scientists will uncover forces, particles, or patterns that we haven't even imagined yet, and those discoveries could completely reshape how we think about space, time, and the nature of existence itself. New inventions like more powerful telescopes, smarter computers, and sensitive detectors will let future researchers look deeper into space and further back in time. With these tools, they might uncover new types of energy, hidden dimensions, or unknown particles that could completely revolutionize our understanding of how everything began. And as our picture of the universe changes, so will the philosophical questions we ask. Future generations may see the boundaries between science and philosophy begin to blur as thinkers combine both fields to explore questions about time, consciousness, and what it truly means to exist. This deeper blend of science and philosophy could help people develop a more complete, more human story about the universe and our place in it. It wouldn't just change science, it could also change culture, religion, education, and how we see ourselves as a species. And just like in the past, every new generation will build on the work of the ones before them. Each new breakthrough will stand on the shoulders of earlier discoveries, and from that growing mountain of knowledge, we might see sudden leaps forward in how we understand reality. The effort to study how the universe began will continue to inspire research in many different scientific fields. It helps us uncover not only how stars and galaxies were born, but also how time and space themselves might have come into existence. As scientists dive into these big questions, they also start to rethink the forces that hold everything together, like gravity, electromagnetism, and other fundamental powers that shape the universe. Right now, dark matter and dark energy are still huge mysteries. Together they make up most of the universe, but we can't see them or touch them. Still, they seem to affect everything from the motion of galaxies to how the universe is expanding. Scientists hope that by learning more about these invisible elements, they can develop new tools and methods to study them. This could even lead to surprising new technologies, perhaps inventions that will help us generate power, improve communication, or design better machines. The ripple effects could reach fields like engineering, space travel, and even everyday life. Studying the beginnings of the universe also brings many different disciplines together. Astrophysicists, philosophers, artists, and even writers all find inspiration in these cosmic questions. These conversations spark creativity and imagination, pushing people to think in new ways. Sometimes, a new idea from philosophy can inspire a breakthrough in physics, or vice versa. The combination of ideas from different fields can lead to surprising discoveries and exciting new paths for exploration. As our understanding grows, schools and universities may also begin to change how they teach science. Students might learn more about how everything is connected, how the birth of the universe ties into biology, chemistry, and even climate science. By encouraging curiosity and asking big questions, we help young minds become passionate explorers of the unknown. This excitement about space and the cosmos can fuel future discoveries and shape a society that values learning, innovation, and wonder. The human journey to understand where we came from has already changed history in powerful ways. Long ago, early civilizations told stories about gods and spirits to explain the stars and the night sky. These myths gave people comfort and a sense of belonging. But as science developed, those old stories began to shift. New tools like telescopes and formulas gave us a more detailed picture of the universe. The Big Bang Theory, for example, tells us that the universe began around 13,800,000,000 years ago from a tiny, incredibly hot and dense point. This idea challenges our imagination and changes how we think about our own existence. Great minds like Albert Einstein and Edwin Hubble helped lead this revolution in understanding. Later discoveries, like the cosmic microwave background radiation, the afterglow of the Big Bang, added even more evidence. Bit by bit, these scientific milestones helped us see ourselves not as separate from the universe, but as part of it. This realization has affected more than just science. It's also shaped art, philosophy, and literature. People have begun to reflect more deeply on life, purpose, and our role in the grand cosmic story. These shared questions about the universe connect people across cultures, countries, and backgrounds. No matter where we come from, we all live under the same stars. This shared origin story helps foster a sense of unity, reminding us that we're all part of something much bigger. Our desire to explore the cosmos has also driven major advances in technology. From rockets and satellites to new ways of gathering data, space science pushes engineers and inventors to dream bigger. But in trying to understand the stars, we also learn more about our own planet. We're reminded that Earth is a delicate home floating in a vast, mysterious universe, and that we must take care of it. In the end, our ongoing effort to understand how the universe began is one of the most inspiring chapters in human history. It's a story filled with questions, discoveries, and the unshakable drive to learn more. From the ancient philosophers who looked up at the night sky in wonder, To today's scientists working with powerful machines and space probes, each generation adds its own thread to the great cosmic tapestry. One of the most important tools we've developed along the way is the scientific method, a way of asking questions, testing ideas, and learning through careful observation. Thanks to this method, we've discovered the laws of motion, the theory of relativity, and the strange but fascinating world of quantum physics. These ideas explain how everything in the universe works, from the tiniest particles to the largest galaxies, and even though these theories were developed to understand the cosmos, they've also helped shape our daily lives. From computers and smartphones to electricity and medical tools, our growing knowledge of the universe has brought countless benefits to humanity. The story of cosmic origins is not just about distant stars, it's also about who we are, what we can achieve, and the wonder of being alive in such a vast and incredible universe. Science, at its heart, is a team effort. It is not something done alone in a quiet lab. It is a global adventure where people from many different countries and cultures come together, share ideas, and build on each other's discoveries. Scientists like astronomers, physicists, and cosmologists work across borders. Whether they are observing the stars from mountaintop observatories or gathering data from satellites floating high above Earth, their work is part of a united mission to better understand the universe. Powerful projects such as the Hubble Space Telescope, launched in the year 1990, and the James Webb Space Telescope, launched in the year 2021, are more than just advanced machines floating in space. They are symbols of international cooperation and shared dreams. These telescopes act like giant eyes in the sky, sending back breathtaking images that show the early stages of galaxy formation, and even hint at the existence of planets beyond our solar system, worlds that might contain life. Every image is a gift, a small clue in the grand puzzle of the cosmos. The knowledge we gain through such discoveries doesn't just belong to scientists, it belongs to everyone. It becomes a legacy, something we pass on to the next generation. This legacy is filled with wonder and a deep desire to keep exploring. It encourages people of all ages to look up at the night sky and dream big. The more we understand about how the universe is built, the more it inspires young minds to ask bold questions. Where did we come from? What else is out there? Where are we headed? In this way, the search for cosmic knowledge connects us. It brings humanity together, reminding us that we are all part of something much bigger, a vast and mysterious universe that we're only just beginning to understand. Our journey to explore space often goes hand in hand with major changes in society. As we expand our view of the cosmos, we also begin to see ourselves and our place in the world in a new light. This connection between space exploration and social change is not new. During the Renaissance, which began around the 14th century, scientists like Nicholas Copernicus and Galileo Galilei changed everything by showing that the Earth was not the center of the universe. Instead, they proposed that Earth moved around the Sun. This idea shook the foundations of what people believed at the time. It also encouraged people to start questioning long-held authorities and led to a period known as the Enlightenment, when science, logic, and new ideas began to flourish. Later, during the Industrial Revolution in the 18th and 19th centuries, humans developed powerful machines that made deeper space exploration possible. Telescopes became stronger, and eventually we invented radio and space telescopes that could see parts of the universe we never even knew existed. These tools helped us discover amazing things about space, time, and even the building blocks of the universe. They changed not only science, but also how people thought about technology, education, and the future. Today, science is more connected to society than ever before. Big projects like the International Space Station, which has hosted astronauts from many nations since the year 2000, show how much we can accomplish when we work together. These international efforts mirror other challenges we face on Earth, such as climate change, disease, and inequality, reminding us that cooperation is the key to solving big problems. Interest in space often increases during times of crisis. For example, during the COVID-19 pandemic, many people turned to science for answers and comfort. Facing the uncertainty of life made people reflect on their place in the universe. In moments like this, science doesn't just give us facts, it gives us hope and meaning. Our journey into the stars is not just about distant galaxies, it is about human dreams, questions, and our never-ending search for truth. Every step we take in space science helps shape the world's future by inspiring others to think bigger, work together, and keep searching for answers. The amazing discoveries being made in cosmology, the science of how the universe works, are especially powerful for young people. When they hear about things like gravitational waves, which are tiny ripples in space and time first confirmed in the year 2015, or about planets outside our solar system that might support life, their imaginations are lit on fire. These ideas make the universe feel like a huge puzzle just waiting to be solved. Young minds begin to see science as something exciting and meaningful. They see teams of researchers from all over the world coming together to answer enormous questions using amazing tools and creative thinking. This shows them the power of working together, and that great discoveries come not just from genius, but from perseverance and teamwork. The stories of scientists who dedicate their lives to studying the stars and galaxies teach important lessons. They show that even when faced with failure or tough problems, curiosity and hard work can lead to incredible breakthroughs, and often the technologies developed for space research go far beyond astronomy. For example, tools created to study the cosmic microwave background, the leftover radiation from the Big Bang, have helped improve medical imaging and even cell phone technology. This shows young people that studying the stars can lead to discoveries that help people right here on Earth. Thinking about the universe also leads to deep questions about life, time, and who we are. Are we alone in the universe? What happens to the universe in the future? Where did we come from? These big ideas help shape a young person's view of the world. They also teach critical thinking and spark creativity, making students more thoughtful and open-minded. Science, when mixed with philosophy, creates a rich and complete way of learning, one that prepares future generations to explore not just the stars, but all the challenges life throws their way. As we continue to make incredible progress in our understanding of space, our view of reality is changing. New technologies and discoveries are teaching us that space is not some distant, unreachable place. It is a part of our everyday lives. Future missions may allow humans to live on the Moon or even Mars. This would change how we think about home, community, and what it means to be human. Also, our understanding of time is evolving. Scientists studying black holes and gravitational waves have found that time is not always steady. It can bend and stretch depending on gravity. This idea, though strange, shows that time is more flexible than we once believed. It may even change how we think about aging, memory, and the passage of life itself. As we keep exploring the vast mysteries of the universe, especially strange things like dark matter and dark energy, we're slowly starting to realize just how little we actually know. It's like we've only just begun to lift the curtain on a much bigger and more mysterious stage. These cosmic puzzles could one day lead to discoveries so powerful that they might change our everyday lives in ways we can't yet imagine. Who knows? One day, we might learn how to travel through time, peek into other dimensions, or even reshape our very understanding of what it means to be alive. If such breakthroughs happen, they won't just be scientific, they'll also touch our deepest thoughts and beliefs. They might change the way we think about life and death, about right and wrong, and about our place in the universe. As we push beyond the limits of today's knowledge, the future may completely transform what it means to be human. With our never-ending curiosity and ever-growing technology, space exploration is likely to change the way we think, spark the imagination of future generations, and even make us see time itself in a whole new light. The universe isn't just a sky full of stars. It's a grand frontier of mystery and meaning that keeps calling us to explore, learn, and grow. One of the most exciting and mind-bending parts of this journey is the search for answers about what might have existed before the Big Bang. This question takes us beyond science and deep into philosophy. Scientists and thinkers are asking questions that challenge everything we know. What came before everything we see? Why does anything exist at all instead of nothing? These are not just scientific puzzles, they are questions that shake the very foundations of human thought. Trying to solve them brings science and philosophy together in fascinating ways. As researchers explore bold new theories, like the idea that our universe is just one of many in a multiverse, or that it popped into being from a strange quantum fluctuation, or that it endlessly expands and contracts in cycles. Each idea offers a different picture of space, time, and our own role in the grand design. These theories force us to rethink familiar ideas about cause and effect. They invite us to imagine how something could come from absolutely nothing. Diving into what may have happened before the Big Bang also brings fresh energy to ancient philosophical debates. Are our lives completely determined by laws of nature, or do we have true free will? Does human consciousness play a bigger role in reality than we ever guessed? Some scientists are even beginning to wonder, could consciousness itself be a key part of the universe, something just as important as space, time, or matter? These big ideas can lead to amazing conversations. They help us see old teachings in new ways and open our minds to possibilities we hadn't considered before. Thinking about these things isn't just for scholars. It helps all of us better understand who we are and what we're doing here. Exploring such questions doesn't just satisfy curiosity. It breathes new life into human wisdom and may help bridge the gap between science and philosophy in exciting new ways. The universe still holds countless mysteries that continue to inspire wonder. One of the greatest mysteries is dark matter. Scientists believe that around 1/4 of the entire universe, about 25%, is made of this invisible substance. It doesn't give off, reflect, or absorb light, so we can't see it with any telescope. And yet, we know it's there because we can see how it affects the motion of galaxies and other objects in space. Understanding what dark matter is could completely change our picture of the universe, and maybe even lead to entirely new laws of physics. Then there's dark energy, an even bigger mystery. This force seems to make up about 70% of everything in the universe. It's the mysterious energy that's making the universe expand faster and faster. But despite its huge role in shaping the cosmos, we still don't understand what dark energy really is. If scientists can figure it out, it might not only answer questions about the fate of the universe, whether it will keep expanding forever or eventually collapse, but also help us unlock secrets about the true nature of space and time. Black holes are another cosmic mystery that never ceases to amaze. These are regions in space where gravity is so strong that nothing, not even light, can escape. Scientists have learned a lot by observing black holes, including the famous image of a black hole's edge, known as the event horizon. But many questions remain. What happens inside a black hole? What is the singularity at its core really made of? And how does it connect to the larger fabric of space and time? Unlocking these secrets could help us finally combine the two great theories of physics, quantum mechanics and general relativity, into one complete picture of how the universe works. And then there's the thrilling search for life beyond Earth. With the discovery of thousands of exoplanets, planets orbiting stars outside our solar system, some of which may have the right conditions for life, scientists are more hopeful than ever that we might not be alone. Special missions are now searching for biosignatures, chemical signs of life in distant atmospheres. If we find even a hint of alien life, it would completely change our understanding of life's possibilities and its place in the universe. Art and culture also play a big role in helping us connect with the cosmos. Poets, painters, musicians, filmmakers, and storytellers are often inspired by the stars, planets, and galaxies. Their work can awaken feelings in us that go beyond what science can explain. For example, imagine looking up at the night sky and feeling a sudden rush of inspiration or wonder. That emotional spark can lead someone to want to learn more about space and the universe. Beautiful paintings of galaxies or films about space travel can make cosmic ideas feel personal and meaningful. Art helps us picture these massive ideas and makes them feel closer to our own lives. Different cultures around the world have also created their own stories and beliefs about how the universe came to be. These stories, whether they are ancient myths or spiritual traditions, show that the desire to understand the stars is something all humans share. When we respect and learn from these many cultural views, our understanding becomes deeper and more complete. It also brings us together, reminding us that the quest to understand the cosmos is something all of humanity is a part of. When we look at something like a colourful nebula or a swirling galaxy, we're not just seeing distant objects in space, we're also feeling something, a sense of awe, curiosity, or even peace. These moments can spark new thoughts and emotions that help us explore not just space, but also our own hearts and minds. For example, the amazing images captured by the Hubble Space Telescope turn complex scientific data into pictures that everyone can enjoy and learn from. These images are not only beautiful, they help people become more curious and inspired to study how stars are born or what black holes really are. Beauty can often be the starting point for learning. When people are moved emotionally by the wonders of the universe, they may be more willing to tackle tough scientific questions. This mix of feeling and thinking creates a powerful connection between art and science. Philosophy also becomes more meaningful when combined with these emotional experiences. When we think about the fact that the universe holds billions of galaxies, we can't help but wonder, why are we here? What is reality? What does it all mean? These moments of deep thought can change the way we see the world. They can make us more thoughtful, more caring, and more aware of the delicate web of life we are part of. Science and art, when they work together, can help us understand the universe in ways that neither could do alone. Art brings feeling and imagination, while science brings knowledge and facts. Together they spark creativity and a desire to explore more. The beauty of space becomes an invitation, not just to enjoy, but to learn, wonder, and search for meaning. This sense of connection is also reflected in how the universe works. Right after the Big Bang, around 13 billion and 800 million years ago, the universe was extremely hot, dense, and full of tiny particles interacting in intense ways. During a period known as cosmic inflation, the universe grew at an incredible speed, creating the enormous connected structure we see today. One amazing discovery is the idea that, in the beginning, all four of the universe's fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, may have been one single force. As the universe cooled, these forces separated, but the fact that they were once united shows us that everything is deeply connected at a fundamental level. Another powerful example of this connection is a strange feature of quantum physics called entanglement. This is when particles are linked in such a way that a change in one instantly affects the other, even if they are very far apart. In the early universe, many particles were entangled. Even as the universe expanded, their connections remained, tying different parts of space together in invisible ways. We can also see these ancient connections in something called the cosmic microwave background. This is the faint glow of leftover radiation from the early universe, which we can still detect today. It comes from a time around 380,000 years after the Big Bang, when the universe first became clear enough for light to travel freely. This background radiation shows tiny differences in temperature and density that eventually led to galaxies and stars. It proves how the early conditions of the universe still shape everything we see today.